Welcome everybody to this year's Antique Television event for CHRS. And we've got a nice schedule of presentations for you today. As you can see up here, after our little time for introductions and a few words about the sets on display and so forth, then we'll launch into the presentations. At 10:30, we've got John going to talk about early RCA color circuitry. That'll be followed by me talking about 1946 Farnsworth television and some of its unique circuitry. And then we'll have a nice lunch break, time to really converse a bit and talk to people and so forth. And of course, eat lunch as well. There's a $5 donation requested for lunch, the same kind of arrangement that they have for the volunteers that come here all the time. So I think somewhere downstairs near the food there'll be a little basket, and you really should put $5 in that. And at 1 o'clock, this is sort of a new and different thing we're going to do this year, is one of the things about antique TVs is antique TV programs. And this is sort of an interesting episode. It's a series called the Real McCoys. Probably a bunch of you are familiar with that. That was actually not one that I had come across in my years of watching syndicated reruns. So anyway, the episode itself is about a television set. And the particular television set in that episode is the Hallicrafters T54. And so we brought one of those this morning on the back table just to have sort of an interesting tie-in with that that particular presentation. And that's all instigated by Fred Deal here. He recommended this, and I thought, well, sure, let's do this. It's a little different. It's not a serious technical presentation, but it's a fun thing to do. So right after lunch, that will be on the agenda. Okay, great. So yeah, we'll leave a little time for that as well. And then after that, both Nat and I jointly will do a little presentation on the restoration of the GE HM-185. That's the pre-war set, the console sitting back there in the corner that you've probably all taken some notice of. And then we'll have a little more time for yakking and dessert at 2:10. And then the last two talks will be John again. He's going to talk about the famous CT100 was not the first NTSC color TV, and we'll hear a bit about this Westinghouse that stole the show. Okay. Oh, okay. I didn't say Westinghouse, so don't worry. And then finally, Nat is going to talk to us about the early days of color programming, and he did update his title to something very clever, which was something along the lines of early color programming, beauty in the eyes of very few beholders, which I thought was sort of a fun way to title that talk. Okay, so one thing that's really a joy to see with this group is over time it's gained some traction in becoming one of the prominent centers of knowledge and restoration and repository of restored things and knowledge, really on the national scene for antique television. John's been very active in producing all kinds of interesting stories technically, and we've had others as well that have had, so the sum total of all of this is now starting to take some, or get some notice outside of Alameda, which is great to see. Congratulations on that, and that's really due to all of your participation over the years, and we hope to see more of that, and I'm sure we will. All right, so with that, let's just take a moment here and introduce ourselves. If you're one of the newer folks here, then take a little more time to really let us get to know you. If you want to use a name tag, we do have those up here, and we would like you to all sign in as well sometime during the day, because then we can get you on the mailing list for future events. But it's great just to take a moment here, a minute or two, to just tell us a little bit about who you are and what's interesting about antique TVs for you. And let's go ahead and sort of do this in unusual order. Let's start in the way back here. Would you like to go first? Here, I'll give you the microphone.
Alan Young, AG6ZE. I'm relatively new to antique TVs. I've done one TV-37U, which was a fun little set to restore. And very pleased to be here.
And let's take it over to Richard while we're working the back row here.
I'm Richard Watts, and the editor of the CHRS Journal. I have restored a number of TVs, sort of vintage, post-war, but not too late. And enjoy this. Really interested also in mechanical sets from the 20s and 30s.
No, you can't have my food. Anyhow, I'm Jim Fink. I just live down the street, and got an MSEE degree, and I've always diddled with television a little bit. When I was, let's see, in the 6th grade, I built a scanning disc mechanical one out of cardboard and erector set motors, and put some neon lights in it, and I tried to do it with a camera, but it wasn't. The selenium cell was not cooperative. I think it didn't have anything over 100 hertz response, so I couldn't get much video out of it. But I could play music into the scanning disc, and it was interesting to look at. And I've worked on a few old color TVs. And those days are long gone, but anyhow, I'm here enjoying it. So that's my story.
Steve Garaventa, 40 some odd years in television, and I just like to come and support all the work you guys do, just to show up and all your hard work, at least someone's listening.
I'm Gilles Vrignot. I built the head end downstairs that give you guys your signals. I started TV servicing in Tasmania when the dinosaurs still roamed the earth. And I'm just interested in all this stuff and happy to be here.
Thanks. Hi, I'm Padma, and I live in Oakland, and I've never heard of, I've been here so many years, and I didn't even know this place existed, but then I read an article, and I was so excited, so I came here last week and signed up to be a member. My background is I'm a software engineer, but I made the biggest mistake of my life when, I was really interested in electronics as a kid, and I grew up in Malaysia, and I would look at all these magazines coming from the US with heat kits, and I was so envious. And then instead of doing electronics engineering, I did civil engineering because I thought, hey, I want to travel, and that was the biggest mistake I ever made. So went back to school, got computer science degree, and here I am. But I wish I had gone into electronics. So I'm really excited to be here and learn from all you guys, because you all have so much experience, and yeah, it's nice to be here. Thanks.
We're glad to hear you.
Yeah, thank you.
I'm Fred Deal, and ever since I was 3 or 4 years old, I liked mechanical and electronic things. And here's a little funny story. When I must have been 4, there was a nightlight, and it looked like a plug. And about 1 or 2 in the morning, I got up and I pulled it out and I put my finger between the pins, and I sure found out what that was. So anyway, and I was always interested in that stuff. And I'll tell you just a little bit more when I do the presentation. So, and I'm very happy to be here. And I also restore antique radios and televisions and a lot of wind-up phonographs. So, and still doing that. And and I'm so happy the building is going to look so good when this is all done. So, anyway, thank you all for what you do, and thank everybody that produces this presentation. So, here's Kurt.
Hi there, I'm Kurt Swanson, and for me, antique television started when I was about 12. Somebody gave me a Spartan TV with a mirror in the lid, and it took about another year to get it all running, but I did, and have been interested ever since. I've rebuilt a number of sets and own a number of sets, including a fair number of early generation color sets. I also did, while I was finishing my engineering degree, I also did some broadcast engineering. I maintained one of the local television transmitters in Sacramento, so I've been around, and I've spent my whole life in electronics, designing it, servicing it, whatever. So I'm still interested in television in general.
I'm Joe Selcraig, and I live in the San Jose foothills. I've been a club member for, I'd say, at least 35 years. And I'm interested in every kind of vintage electronics you can think of, pretty much. TVs fascinate me because of the CRTs in them and the camera pickup tubes, oscilloscopes too. I have an interest in those. I have around 40 sets, which I know is not a lot by some people's standards, but I do have a few. Currently, I'm working on 3 TV 37s for the club, and they're all working. A little more work needs to be done on them, but just about done with those. I used to work at Amdahl, which was a mainframe manufacturer here in the valley, and now I work at the sewer plant, the largest sewer plant in the area, as an instrument tech. I mean, where do you go from Amdahl? You go to the sewer plant, which is actually more to that than you would think. And if somebody wants a tour, I'd be glad to give it one. You'd be surprised what's going on there. It is, yeah. There's a lot to it. And that's, in a nutshell, what I have for now. Thanks. I am really enjoying this, by the way.
Yeah, I'm David Bellici. I'm the videographer for CHRS. And I go back as far as television, maybe early 50s. Our first TV set was a 21-inch Sentinel. And later on, my father, he was kind of cheap, and we bought a second set, used and so forth, and had a color wheel, RCA color wheel adapter on the back of that TV. But what's really amazing about those TVs back then was the fact that they had so many adjustments in linearity, horizontal drive, and so forth. That fascinated me. And eventually, after I graduated from high school, I went to City College of San Francisco, where I got involved with the radio TV department there, not only taking classes, but also lab assistants. And back during that era, we had the Dage black and white cameras, the Vidicon cameras and so forth. We had the camera control units in the control room. We had the Sony PV100 2-inch helical scan machines that we had there when I first got there. They had an Ampex 1000A prior to me arriving at City College, so I learned a lot about television there. Then I went into the military, the Naval Reserve, and then when I came back, I went to John O'Connell Technical Institute there under the leadership of John Nielsen, and there they taught us, television as far as preparing us for becoming a broadcast engineer in the television industry. So after I finished John O'Connell, I went to KBHK, Channel 44. I worked as a broadcast engineer there for 30 years. And so it's been on and off since I retired from there. So that's my experience with television.
Next. John?
Oh, yeah, thanks. I'll stand up so people can see me. John Staples, ham called W6BM, and I'm a scientist at the Lawrence Berkeley Laboratory. And my fascination in television goes way back. Back when I was a kid, my father would occasionally take a sales trip up to the East Coast, and one time we dropped in at Radio City in New York City, where RCA was presenting some of their very first color sets at Radio City. And I was just fascinated with this. I have to see this, so we went on over, saw these sets. I talked to an engineer and asked him some very stupid questions. Well, not totally stupid, but pretty much stupid. And he probably said, well, all right, kid, get out of here. But since then, gotten very interested in it. I have a nice collection of, I think, some of the real landmark sets, all the way from the 630 TS, which I acquired back about 1956 when I was still a kid. The companion, the 621 TS, both came out on the same day in April of 1946. So the CT100, a projection set, an RCA projection set. It is the 648 one that doesn't have the phonograph. So it's just the set itself. The 648 PTK had the radio. No, the 648 PTK had the radio and the television. I have just the TV part, CT one. Yeah, it's actually 9 PC41, and I have that, and actually a total of about 40 sets at home. Half of them are little transistorized sets. And got interested in cameras. Have built one iconoscope camera. We actually have 2 more iconoscope cameras. One of them belongs to CHRS. It's residing at my house, fully functional. This is two of these World War II cameras that I have restored. One came from Richard Deal, partially restored, and I finished the job. Also a Orthicon camera, which I finished the restoration on its operation. I used a 5820 Orthicon in it. I've gotten quite interested in writing, doing a lot of write-ups of all these things. And, well, that's, I think that's about all I can say. That's probably too much to say. Nat.
Good morning. Okay, so I think, you know how you imprint on something, like animals do and people do when you're very, very small? I think I imprinted on a television set because when my mother came home from the hospital with me after being born, my dad bought the family's first television set, so I just grew up with it. I remember seeing color TV when I was 5 years old, and it was The Wonderful World of Color in this mansion. A wealthy family invited us over, and a bunch of other kids. 61, right after Disney had been on for a little while. I think it was, yeah. And it was a big RCA, I would imagine, but we were outside of Philadelphia, so they had a good NBC station that was, at the time, was owned by NBC. Not anymore. It's now CBS. But the program was, it featured, and I still remember, it was so impressive. I mean, even though I was only 5, I can still remember that one of the episodes was Donald Duck quacks up, and he's given a calming, he takes a calming course to calm him down and speak normally, and he's like, he's not using that voice anymore. But then he loses his temper and goes back to the standard Donald Duck. I remember it because it was like, whoa, this thing is in color. And hearing about pre-war TVs from my father and other people, oh yes, we saw this TV. There were 2 in my little town. One belonged to the local mad scientist who built it, and he was a guy who, named Simmons, I just remember Mr. Simmons built this TV. He built a pre-war TV. My father saw it when he was like 11 or 12. And I just heard about it and never saw the set. And I think it just got my interest going. And then as I was growing up, I'd see an old TV set and go, whoa, how old is that? How old is that? And finally got one when I was in college. It was a 721, and I still have it. And you've seen it. So in any case, I'm not in, my field happens to be linguistics and working in museums. So the museum has somewhat of a connection with the history of communications and broadcasting and all that, but I don't have the engineering side of this at all. So all thumbs when it comes to repairing these things. Okay. Anyways, and I live in next to Monterey in Seaside.
All right, got a couple more people that came on in while we were doing things. You want to just introduce yourself? Sure.
Yeah, hi, I'm Rob Johnson. I've worked in tech here in the industry for a while, mostly digital video stuff. I'm currently working at NVIDIA doing digital video stuff. And I've just been interested in TVs and tubes and stuff like that for my whole life. And I kind of hooked up with Jerry Grolke, a guy who's kind of known by you guys. So I ended up with a lot of his TVs. And so I've just been kind of sorting through those and stuff. So yeah.
Tom Bonomo from Reno. took 4 hours to get here. I was in video early on in Hollywood in post-production, and then finished my engineering degree and co-founded a company called DRC Switcher, and we made a big master control and switchers for TV stations, and then we sold that company to Ampex, and that kind of ended my video career. I went into venture capital, but it's been fun ever since. Who's next?
All right. I'll finish off this. We didn't give you a chance yet to just say a few words to introduce yourself. Yeah.
I'm Gary Embler, and I work as an engineer, but I also am interested in antique radios. I have some portable RCA sets that I'm working on restoring, but I also have a Heathkit color TV, which was, I believe, the last vacuum tube color TV that they did. And I'm not the person who built it, but I am the person who is keeping it running or trying to. So that's all.
Very good. There's a few more likely to come later today, but for now, that's who we had. I'll just introduce myself as well. I'm Tom Albrecht, and I've been helping to organize this event now for 6-7 years or however long it's been. I work in the high-tech industry for a small startup company. I guess I'm a physicist by training. As far as antique radios and TVs, antique radios go way back. As a kid on my bicycle in town going to rummage sales and getting this for 50 cents and that for $1.50 and coming home and either making them work or taking them apart and making something else out of them. TVs, I got started in that just by buying a Motorola VT71 at a CHRS swap fest, probably mid-90s, right around there. And I thought that was a lot of fun. It was much more interesting than working on antique radios, at least to me at that time. And ever since then, I've been restoring sets. I don't have a huge collection. I don't really want lots and lots of TVs cluttering up the house, but still I have 10 or 15, which is plenty. And what I do to keep the interest up is I do lots of restorations for other people. And this is just perfect. You get to have the TV, you get to work on it, you get to know how it's designed to fix the interesting problems, and then magically it disappears and goes back to its owner. So that's my main activity with antique TVs. Okay, so as you can see, this is a pretty interesting group of people, and there's a lot of knowledge here relating to the broadcast industry or the programming and lots of things, the technology of the broadcast equipment, cameras, and the receivers. So have fun today, get to know these people, and learn as much as you can from each other. With that, I think we will go ahead and launch into the day's presentations. The first one is going to be John, so let me turn this over to you, and I'll get your item up on the screen.
You set up the computer for me? All right, the reason I got interested in this is just recently was working on a couple of vector scopes. One of them downstairs, which was actually a gift from Joe, it was a Tektronix 520, I think, that went bad, and then brought it back to my house. I've got one just like it, which I was using as a prototype to find out what was wrong in the one that went bad. And then I have another one that I fixed up too. So I thought, as long as I'm playing with these color demodulators, I would be interested in knowing what the early RCA color TVs were doing with their demodulation. And were they cheating, or were they using the full bandwidth that was available? So what I'm going to talk about, mainly I'm going to talk about how the color signal is actually put together. And then at the end, toward the end of the talk, I'm going to talk about, starting with the CTC2, the CT100, of which there are 3 represented right here, me, Tom, and Tom. And Kurt, sorry, we have 4 working CT100s.
Mine does not work currently.
Okay, we got 3 working CT100s. But take a look at these sets and their sons and daughters and find out what was going on there. Okay, so I thought I'd start with a nice colorful picture. And the human eye is a remarkable device. We have three different color sensitive sensors, the cones in our retina, which differentiate blue, green, and red. The most sensitive ones, of course, are the rods. That's where your color vision, or your night vision comes in. So if you're after dark, you're not seeing much color, but you're seeing black and white due to the rods. Those three colors in your rods, you can assemble the whole spectrum that the human eye can see. Where does yellow come from? We don't have a yellow rod, but we have a green and a red. They go together and they make yellow. What about violet? Where is violet? Is that a spectral color? What makes violet? Red and bluish, yes, they're off the ends of the spectrum. And can everybody see the numbers here in these fields? Everybody see the numbers? Yeah. So nobody here is colorblind. That's great. Yeah. Okay.
Those do look like color blindness tests.
They are. Yeah. They are.
Those are color blindness tests. That's right. Okay, so the CBS, I want to show you just to start off what happened with this, how the CBS system worked. I wish I had a pointer, but if the CBS, but let's say that the CBS wants to transmit that pattern that you see up there, alternating diagonal strikes of green, red, white, and so on. And what does it do? First of all, there is no concept of signal compression in the CBS. They just took the three colors that they would get from a three-color camera. They would have a rotating disc. You all know how the CBS system worked. They had a rotating disc in front of the camera tube, and it would break it up into alternately red, green, and blue images. And each one of those was interlaced. It was an interlaced system. Each one of those fields, six fields went together to make six frames went together to make a field, and there were 144 fields per second in the CBS system, and after 6 fields, you had a total of 24 frames per second. Okay, 24 frames per second. This all still fit within the 6 megahertz channel width. The 6 megahertz channel width was actually dictated by, I think pre-FCC, it was FRC, back in the 30s, when the original television spectrum was laid out with 6 megahertz channels, and we have been saddled with that ever since. Anyway, no thought made of signal compression. How do you squeeze the signal into a compatible color signal that can be seen on a black and white set? But that's what the CBS system did. 405 line, previously I think it was about 343 in some of their early experiments, but it wound up to be a 405, which is interesting because that was the same as the pre-war BBC line count. The 405, but a different frame rate.
They had 50 and we had 60 hertz?
They had 50, right. And it was interlaced, and it wound up, initially it was not, it was full double sideband, and they went to vestigial. And so the original BBC channel width was even less than 6 megahertz. Okay, so I keep, when I say RCA, I really mean to say RCA, Hazeltine, Philco, and all the others that were in a consortium to establish the first NTSC color standards. But in any case, the CBS system made no attempt at image compression. So, but the human eye interprets colors in a little different way. The NTSC standard takes the 3 color signals and converts them to 3 other signals. If you have 3 equations, you can establish a set of what you might call basis vectors to transform linearly those three signals, red, green, blue, to three other signals. And those three other signals, one of them would be the brightness or the luminance component of that signal, and then two other signals, which are called I and Q, and we'll get into that in just a little bit of why it is even called that, which will convey the additional color information. So this luminance signal, this is the reason for the compatibility with black and white. The luminance signal was the black and white portion of the signal, and you could see it on a black and white set, discard the color information that's already mixed in there, or on a color set that's transmitting a black and white signal, the color set would reproduce the black and white signal correctly. So here's how those signals were put together. There's a linear transformation. I wish I had. Oh, we don't have a stick, but take the original red, green, and blue signals and combine them with in linear sums to produce the Y, which is the luminance signal, the black and white part, and these other two signals, I and Q. The significance of this, if the scene is entirely a black and white scene, in other words, you take and you do on a color camera, do a white balance on my TK76, do a white balance on a white sheet, all the signals will be amplified to the very same amplitude. Okay? So let's say you're doing a white balance, all of the RG&B signals, notwithstanding the actual gain of the amplifiers or of the pickup tubes, but they are all adjusted by varying the gain of the amplifiers, so all of the three of those signals will have the same amplitude for a white balance or a completely monochromatic image without any color in it. And if you take a look at the way the signals are put together, this Y signal will be the sum, 30% red, 58% green, 11% blue. Those all add up to 1. But you take the other two signals, the I and the Q signals now, and put in the same amount, the same amplitude of red, green, and blue, you'll see that both of those sum to 0 because there are some minus signs in there. So they will be summed to 0. So a monochrome signal from a subject that has no color content will produce no I or Q amplitudes. And then at the other end of the chain in the receiver, these same signals, the I, Y, and Q signals that are decoded in the receiver, with this inverse matrix, can be converted back to the red, green, and blue signals. And that's, as I pointed out, that's what happens when you do the white balance in a color camera. What I did here is actually I set up a spreadsheet where here's the matrix, and I could enter in this column up here, say some color signals. So in this case, I added no red, but some green and some blue of amplitude 1. Multiply it by this matrix here, and the Y, I, and Q signals come out. You see right there. The Y signal is 70%, and we get two signals. Actually, they're both, in this case, they're both negative. The luminance signal is always positive between 0 and 100%. The two other signals, the I and the Q signals, can be negative or positive. So you want to be able to transmit both polarities of those signals to the receiver. And then what I did is I simply took the inverse matrix of there, took those values, put them back here, and recovered the original red, green, and blue amplitudes. It didn't turn out to be 0, 1, 1 because I was using 2 decimal instead of 3 decimal places in the matrix. But that's how these matrices are put together. So, how can we use that to our advantage? Turns out that we have 3 signals. We have red, green, blue, or the transformation to luminance, and then the 2 other signals, Y and Q. But how would we deal with three unknowns to send to the to the receiver. One of the things that we can do is remove the luminance value from the color signal and produce what's called a tri-stimulus diagram right here, which is a combination of the color signals transformed into a two-dimensional plane. Okay, and the luminance signal is removed. Well, it turns out that the human eye has this characteristic, and this was actually the conceptual breakthrough of the compression algorithm for color television. And this was this was a very important conceptual breakthrough that was found. What I did here is I overlaid on the tri-stimulus diagram what would happen, and this was done experimentally by taking observers, having them view very small patches of color on a gray background, and how they could detect those patches of color as these patches are just simply made smaller and smaller and smaller. And it turned out that as they reduced the size of these patches, that their perception of the color of these patches tended to lie across this so-called orange cyan locus right here. And you can see as these patches were made smaller and smaller, the perception of those colors would lie closer and closer to that line. In fact, when you this is not lost, for example, on lighting directors in movies. And if you look at movies, some people look at movies on a vector scope, like some people listen to their sound on an oscilloscope. If you look at a movie on a vector scope, you'll see that a lot of the times you're looking at the so-called orange cyan, which is actually skin color and sort of dark blue background. And you see very little of that other orthogonal axis, which is the purple-green axis. And movie directors seem to have glommed onto this a long time even before this effect was actually scientifically seen for color television and used as a compression mechanism. So you probably have now guessed that what I've been talking now, these I and Q signals, are the in-phase and quadrature phase signals in the coding or the modulation algorithm that's used to assemble the color signal. Okay, how do we get that color signal transmitted to the receiver? It turns out that the 15750 kilohertz horizontal scan frequency has harmonics all the way up through the rest of the video bandwidth. 15750 for black and white. It turns out 15734 for color. That's a whole nother story that I could talk about some other time. I'm not going to get into that now. It's a great story. And I'll say just one thing about that. Because of that, a 1 hour videotape will run over by 3.6 seconds. So if you're really timing your network broadcasting, that change will make your 1 hour videotape run over by 3.6 seconds. That's all I'll say about that. And people who know probably understand that. Okay. Anyway, the harmonics of the horizontal scan frequency, 15750 or whatever you want to call it, there's empty places in there. If you take a look at a video signal on a spectrum analyzer, you'll see all these empty places. And it turns out that you select a signal which is some multiple of 1/2 of the 15750, and all its harmonics now, because it's taken as 1/2 of that 15750, will lie between all these harmonics of the 15750. And so we're going to be putting this color subcarrier signal, coding it up in some way, and we're going to stick those into those empty spaces in the video spectrum. Okay, so how we're going to do that? Well, here's what the 6 megahertz that we are dealt with, and we have to fit everything into this 6 megahertz. We have an audio subcarrier that's a quarter megahertz below the top of the channel, and then we have the picture carrier, which is 1 1/4 megahertz below the bottom end of the channel. This is called vestigial or single sideband, or almost single sideband video transmission. All the video for an amplitude modulated signal, all of the information is actually contained in the sidebands. You don't need both sidebands. You can do it with one sideband. And it's easier to include a little bit of the other sideband to keep kind of a phase linearity in the filters that are used to generate the signal. So where are we going to put this color subcarrier? Well, as you know, it's modulated onto what turns out to be a 3.58 megahertz subcarrier, or the burst frequency. Okay, which is the burst frequency, and
I only thought, because I used to have a television set that I bought when I was in the Army, and it was a POW NTSC switchable set, and it had that marking on it, 3.58, and then it had some other one with 4
point something. It's about a megahertz. It's about a megahertz layer higher. That's right, because they have more channels. They have 7 megahertz channel or more to stick all that into, so they can move it up. Okay, so it turns out that the selection of that frequency, 3.58, was actually a long and drawn out process. There were a number of experiments done with expert observers, which would look at a color signal that's encoded with various choices of that subcarrier frequency, some of them higher, some of them lower. And it turned out that the choice that the experts really didn't see all that much difference in that choice. But as you move that down, the black and white signal, or display on a black and white set, would show a lot more chroma grain, because it comes more into the part of the video spectrum that even lousy receivers can display. So the final choice of 3.58 was sort of arbitrary. They had to choose something, and so the 3.58 was the frequency that was chosen, and I think it's equal to 455 times 1/2 of the horizontal scan frequency. I think that's what the number is. Okay, so we see there that color subcarrier, the signal, the color signals that we're modulating on that subcarrier have their own bandwidth. Okay, and so how far are those sidebands going to branch out from that 3.58? Well, they can't go up as far as where the audio carrier is, so that has to be cut off, but they can extend downward. Okay. But from the experiments on the eye acuity and on which axis was the most sensitive to small changes in color, the orange cyan axis, the eye had better acuity for small objects on that axis than the green purple axis. So the eye signal, or the in-phase signal, and we'll come to what that really means in just a moment, was chosen to modulate the 3.58 and allow the lower sideband to extend not just a 0.5 megahertz. The Q signal bandwidth was restricted to a 0.5 megahertz, so the sidebands on the Q signal occupied plus or minus a 0.5 megahertz from that chroma burst frequency, 3.58. But the I signal was allowed to have a single sideband signal overlapping down even more, down to a full 1.5 megahertz. Okay, and down here, these are what the filtered frequency ranges of the I and the Q signal were. The Q signal would lop off at about 0.5 megahertz. The I signal would go to 1.5 megahertz. Video signal would go up to about 4.1, 4.2. Okay. So we have this mixed, funny signal. Let's look at it again. The Q signal is a full double sideband suppressed carrier signal. The I signal is double sideband suppressed carrier, except that additional sideband is extending down to 1.5 megahertz from the color burst frequency. Well, first of all, the first question is, and I was talking with Chris the other day, he was asking me how this was done. I was hoping he would be here. I have actually two explanations for how you can actually put these two color signals onto the same frequency, the 3.58. I have a very real math-intensive explanation that you don't want to hear, and I've got a non-math explanation, which ask me about, but not now. It turns out that a double sideband, if you have two double sideband suppressed carrier signals that are modulated on carrier phases that are 90 degrees apart from each other, they can be separated by synchronous detecting those signals in the receiver. On the other hand, a single sideband signal, if you synchronous detect it, it is not sensitive to carrier phase. It's not sensitive to carrier phase. So the demodulation of that part of the I signal that extends down will actually bleed into the demodulation of the Q signal. And it's filtering in the set that would eliminate or reduce the amount of cross-color contamination due to that. So the idea was to get as much of the color into the spectrum as possible, making maximal use of that physiological aspect of the human eye that was most sensitive to the small patches on that magenta-orange axis, having to deal with some amount of cross-color and deal with that. So we're almost getting to the point where we're going to actually talk about about the receivers. So what is the resolution of these signals? As I'm already pointing out, it's about 0.5 megahertz. That's a good resolution of both signals because they're double sideband suppressed carrier, can be independently demodulated in the receiver, and then that other sideband, which is lopping off lower, gets mixed in, and it depends really on how the filtering in the receiver is doing, which covers how much cross color is going to be evident. Okay. All right, so how do those signals get actually transmitted? They get transmitted on the 3.58. The 3.58, in the receiver, there's an oscillator that is synced to the 3.58, the burst signal. Burst signal occurs in the back porch of the horizontal sync, every pulse. It's a crystal oscillator. I'll be talking this afternoon about a receiver that does not use a crystal oscillator for the burst, which is a surprise. And the relative phase of these generated signals can be related to the color that is being produced to produce that signal. Remember, the I signal is on that orange cyan axis, and the other one is on the green-purple axis. If you have these two phases for the two signals, the combination of the I and the Q can actually occur to any phase within that circle of phases around 3.58 megahertz. Here's what the signal for a set of color bars would look like. You can see right here, right after the back porch, you can see the burst signal, followed by a white, and then through the set of the color bars. Each one of those has a different phase at 3.58, which is reflected by a different angle that phase makes in that vector diagram up there. Let's take a look at what we actually see in the vector scope. You can see up above. This is actually a photograph of the vectors. This is my head end at home. Not as elaborate as what Jill has, but it's fun to play with. And here is the color bar pattern, and the position of the phase and the amplitude of each one of those signals as it goes through the array of color bars is represented by an amplitude which is the distance from the center of the diagram, and the phase, which is the rotation of the diagram relative to the left hand. You can see actually that little short one right there from the center going to the left. That is the burst signal. What are those other two signals? In fact, if you've always seen it with SMTP color diagram. What are these guys at the bottom? Does anybody know what these guys? Ever looked at those? Gilles, you know, so anybody else? No. What are
My
they?
childhood memory, that's where they put the call sign.
Okay. All right. Yeah, what are, we always look at those. It's kind of sort of bluish and a little bit purplish and kind of dark. And what are they doing there? Okay. Those happen to be in a signal generator that generates this test pattern. The signal generator also generates two more pulses. And you can see up there on the vector scope, one that's labeled Q and the other one is labeled -I. Those are there for test purposes. The I, they actually transmit a negative I signal and a positive Q signal, and that's what these guys here, and you can see they're both actually bracketing the blue color. One's a little bit on the magenta side, which is a Q signal, which is this guy here, and the other one's a little bit more on the cyan side, and that's this guy here. So those are the test signals that are actually a pure, I think 30 or 50% I and Q test signals, the ones in the bottom. That's what those are. Gilles.
John, it's useful to point out that one full circle on the vectorscope is one cycle at 3.579545.
Okay, thank you, Gilles. Do you want to, okay, did everybody understand that? Or need more explanation? Okay. Also, you notice that you seldom see that, but you see here in the black, there's also a slightly, these little guys here, a slightly darker than black and a slightly larger than black right at the bottom. And a lot of pattern generators will also put that too. If the brightness control is set correctly, you won't see the darker black than black. Here I've got the brightness control up a little bit. So you can see those two guys there. Normally you don't even see them. But anyway, that's the mystery. And of course, the one with the question mark is a full luminance bar. Actually, this white here is actually 75% white in the pattern, but that's 100% white right there. So that's what's inside the color signal. Okay, now. That's right. Blacker than black is, well, it's way far from the sync pulse to begin with. And it's only 4%. It's only a little 4%, and it's within the raster. It's not around the back porch. Okay, so finally, this is the subject of the talk. How do the color sets do this? Here's how a color set actually does it. The signal comes in the color set. The color subcarrier is filtered out from the monochrome. So you have a amplifier up here for the luminance part. That's filtered. There are ways to do that. The nicest way to do that was with a comb filter, where you can. The comb filter will actually get rid of all of the side bands of the 3.58 megahertz and route it over to the adders. And then the color signal comes down and is separately demodulated. There's two demodulators. Each one of these demodulators is fed the burst signal. One of them is at 90 degrees with respect to the other one. It's double sideband suppressed carrier demodulation. Then they go to phase splitters because some of the matrix things requires positive values of Q and I, and some of the matrices requires negative values of Q and I, so that's why there are phase splitters there. And the really beautiful part is this resistor network right in the middle, where these signals are added together according to that equation that you saw a little while ago. And the Y signal is then added in, and you get your red, green, and blue signals are going to the CRT. So that's what an ideal color set would be doing. Each one of these guys would have its own filter range, 0.5 megahertz on the Q signal, 1.5 megahertz on the I signal, 4.2 megahertz with a comb filter on the luminance of the Y signal. So that's what an ideal demodulator would do. In fact, if you're working with nice, Tektronix demodulators, that's what's going on in these guys. But what do the color sets do? How much difference are there? And so I took a look at the early receivers from the CTC2, which is the CT100, up through the CTC 7s, and beyond that, they're all kind of the same. So what were they doing? And sorry for the schematic, but there it is. There it is. Here's the CT100, and if you take a look, along the top is the luminance channel. Down here is the chrominance channel. Here are the two demodulators, the 6BY6s here and here. One is for I and one is for Q. Here are their phase splitters right here. So you get a plus or minus Q signal right there. You get a plus or minus I signal coming out of this phase splitter. And you see the resistor networks right there. That's just really classic textbook. They're doing the very same thing that those linear matrices are doing. So you recover immediately these three color signals. They threw a couple stages of video gain, DC restores, and go right to the grids of the cathode ray tube, the 15 GP22. And so that's just classic. And that's capable of full decoding of the resolution of the signal. Let's move on to the next set, which is the CTC2B. Now the 2B actually is the CT100, but with a 21-inch tube. Not exactly, because there's many differences. But the color circuits in the CTC2B are basically the same as they are in the CT100, which I didn't know that there was a CTC2B with a 21-inch tube. The early 21 AXP22. Say again.
21 CT55, I think, is
right in the lower right.
Yeah, right there. Thanks, Tom. And so I was surprised. I didn't know about this set, but there it is. There was a 21-inch set from RCA that fully decoded all of the resolution that was available coming in from the color signal.
It was available for Christmas of 1954.
Because the production of, I'm going to talk about this a little bit later, but the production of the CT100 ceased about a month or two after it began production. And so that was a very short-lived production run. I'll talk about a little bit about that in my afternoon talk. Okay, let's move on to the CTC4. Now there was no CTC3, but actually there was a CTC3. Does anybody know what it is? What it is, it was a convergence board. They contained convergence electronics for the later color sets, but there was no CTC3 color television set. It was a don't know. I don't know where it actually cropped up, but it was a convergence board add-on that was used. Anyway, here's the CTC4, and it only demodulates the 0.5 megahertz bandwidth of both the I and the Q signals, and you can tell that because there's only one there's only one signal coming through to the demodulators. It demodulates, if you actually change the axis on that polar plot, the I and Q plot, if you move around a little bit, one of those axes is an R minus Y, and another one is like a G minus Y or a B minus Y signal. If you change the phase of the signals being fed back into the demodulators, you can recover those signals, and you're only going to use a 0.5 megahertz bandwidth. You're not going to use any more of that additional bandwidth in the I signals. And so they get put together. It turns out that the Y signal is actually fed to the cathodes, and the color difference signals are fed to the grids. It's another way to do it, so you don't have to combine them before it gets to the CRT. But anyway, starting with the CTC4, they're not demodulating the full signal. CTC5, same thing. They're using a little different technology. Now they're calling it, instead of the I and the Q signals, they're calling it the X and the Y demodulators. There was apparently some sort of a patent dispute. There was an objection to actually using the terms I and Q for those. I don't know what it was. Nate, do you know? Okay.
Zenith actually invented RYBY, as I recall, and there was no love lost between Zenith and RCA. They were peeing on each other.
Actually, this afternoon I'll mention something else there, which is kind of related to that. Anyway, starting with the CTC4 and all the sets down from there through the CTC9, which is the last one I looked at, they were not using the full bandwidth of the color signals. This is my last slide. So only the CTC2 and the 2B they fully, for RCA, only demodulated the full bandwidth of the signal with the color crosstalk that would occur above 0.5 megahertz in that channel. So, and end up with a nice picture off the screen of my CT100. That's it. Any questions? Kurt, would you please? Here's the mic. Add a little bit to that.
I'll give a little postscript to this, and that is I and Q demodulation actually came back. And high-end sets starting around 1980 had I and Q demodulation again with full bandwidth, but it was all done inside of an integrated circuit, so it was invisible to most of the people in the work, in the TV repair / TV viewing world.
One would expect, of course, now with the ATSC signals and the tremendous amount of video compression that we now have in the present digital color, where we can squeeze two full depth into a 6 megahertz or several reduced depth into 2 megahertz into 6 megahertz, and the video compression algorithms have now come so far, and they all use this characteristics of the human eye, the same way that audio compression algorithms use the characteristics of how we hear sound. The same idea. Okay. Well, thanks everybody.
Thank you, John. Very interesting talk, as usual. I had to learn a lot of that stuff when I finally got around to facing a color set for the first time with that CT100. So I recognize a lot of that schematic and everything you just described. You had mentioned that INQ came back in the early 80s. That's also the time frame I remember when the comb filters first appeared. Were those coupled?
They used comb filters on sets that didn't have INQ because it gave better video performance. But the very They used comb filters in sets that still used RYBY, but the most expensive, highest performance sets would have both. And basically, they went back to INQ because now they had a tube that would basically and video system that would basically show that enhanced resolution. And again, it lasted all the way to the end of NTSC, but now it's all just interesting.
Well, very interesting history. That's what we are all here for, to remember that and marvel at it, because a lot of really cool things were done. Any other comments or questions relating to John's talk?
This full modulation that was on the CT1, this full signal demodulation that was on the CT100 and the one right after it, I'm wondering if Sony went back and grabbed the full color signal.
They did not early on.
Early on, okay. But later on they...
Yeah. First generation sets from other manufacturers did have first generation color sets from other manufacturers also had INQ demodulation, some of them, but it pretty well disappeared really until it got integrated into an IC. So, you know, to my knowledge, Sony didn't do it in their early Trinitrons. And again, the resolution on a Trinitron really isn't all that good. So you weren't going to see it. So there wasn't a lot of point in doing it.
Go ahead. I learned this from Kurt, and I checked it for myself. When you have 4K now on a screen, the eye really cannot perceive that much resolution. So therefore, and I even compared with a guy's iPhone. Maybe that wasn't a good comparison, but I can take my glasses off because I'm legally blind and I can see the pixels. So I was able to compare one picture from another, and they were really great resolution, but there was no difference. I thought, well, what? Well, then what's the use?
That's interesting because I don't know. I think I can see it. So I don't know.
Most people can't. I mean,
yeah.
Maybe a thing like audio perception where different people hear.
Yeah. Well, and clearly it does require a big screen.
Yeah,
to see it.
I can't tell.
Yeah.
I mean,
That makes me question my own observations. I should look again and see if I can really see the difference or not.
With a pad like this, like an iPad.
Yep. Yeah.
I was able to see it.
Yeah. But anyway, that was great to go through that stuff about the sensitivity of the human eye and the resolution for the different color axes. Yep. It made the whole thing possible. Yep.
Well, I have a CBS color question. So I'm going back to 1951 with a scanning. With a scanning disc, I'm wondering. I've seen the wheels when they're stopped, and they have this jagged edge corner, and then back like this. And there's like I think they put 6 of them on a wheel, and red, green, blue, red, green, blue, red, green, blue, and they had 6 plates or color plates, I guess. And when this thing's spinning at how many millions of revolutions per second, very quickly, not that fast, but I'm wondering how many scans occur per color section on the wheel, whether it's one full scan for each color or because they're interlaced.
Each unrelaced scan is 1/144th of a second.
Okay.
6 of them go together to make a full frame at 24 frames per second. Mm-hmm. Okay, and so it would make sense that the color wheel would have 6 sectors, red, green, blue, and would rotate once. It would rotate once for 1/124th of a second, a full field. That would make sense to me.
Mm-hmm.
So in terms of how many lines?
Yeah. Well, each line is each field is a half of a 405 line.
Right. Half.
Half of a 200.
And so one color passes the field.
One color passes the field for 101.
Okay.
144th of a second.
Okay. And not a frame.
And the color in the wheel, I would imagine, kind of follows as it's scanning from top to bottom.
Right, and that's why they get the bend.
And that's why exactly.
And I've always wondered what it would look like if you got the thing out of sync. Because there's 3 colors, and you could, instead of having the red one pass when the red color's going, have the green one pass and get it out of sync. It's not the same as messing up the tint control.
Well, there are some videos that are available that show the wheel actually speeding up.
Uh-huh.
So you can actually see it before it locks.
Okay.
You can actually see it before it locks, then it locks in, and then you get the full color.
Very interesting. That sounds like a fun demo for some future gathering like this. We have a couple people who love to do technical demos, and somebody reconstructing a CBS system might be kind of interesting. Yeah, exactly. Richard would be a candidate for that. You'd be a candidate for it. All right. So I have one last question on this same subject. I had always had the impression, but I'm not sure if it's correct, Was the CBS color signal compatible with black and white or not? So you got all kinds of nasty flickering.
You had to modify your black and white receiver just to receive a CBS color broadcast in black and white. All right. You had to modify a black and white receiver just to receive a CBS color broadcast in black and white. And it's interesting when, if you don't mind, I'll steal a little bit of time here. When CBS announced the color system and the FCC adopted it, the sale of existing black and white TVs stopped. Nobody could sell them. Wow. And so the manufacturers, a lot of them thought this was ridiculous, and they needed to sell sets. So they came out with, some put a socket on the back where you could plug in a CBS converter. Others would make a switch that would switch the horizontal and vertical standards in the set over to CBS.
Vertical would have to go from 60 to 144.
Yeah, and horizontal changed too. And so I sold it a while back, but I actually had an Admiral conversion kit in the box that would allow you to retrofit your Admiral to then plug in a CBS color adapter. But that allowed manufacturers to continue to sell with the idea that, when color was ultimately perfected, you could buy it. But when the first CBS broadcast was done at WCBS, they estimated that there were no more than about a dozen people able to watch it of any sort. So their triumph was a little hollow.
I never was able to find that newspaper article that I recall online. I surfed. I was looking for this article that said, local amateur builds color wheel, and he uses a fan motor, a Variac, and made his own color wheel, according to what maybe Popular Science or something told him how to do it. And that's probably the majority of people that saw the CBS programs in color had built their own sets, because you'll see in my presentation there's a whole month when you could buy a CBS color TV. One whole month, and then they recalled them all.
You imagine most of the sets that we're watching were CBS sets, were owned. I imagine most of the sets were owned by and watched by CBS people. Literally there was nobody else other than experimenters.
All right, I suppose we better move on. But these kinds of discussions are great. That's what this event is all about. And continue that during the lunch hour. And if something really interesting comes up, we'll bring it back and get it recorded as well. Okay, in any case, no question why the CBS system failed. Totally incompatible. Many reasons why that was just not a good idea. So the color was good. Yeah.
Do something like that.
Just to end on a more humorous note, can you guys visualize the size of a CBS color set if it had to be that screen? How big the wheel would be?
A couple of feet, at least.
It'd be pretty scary.
Yeah, don't stick your finger into the buzzsaw.
I got just one more.
Okay, sure.
And that is talking about what CBS color might have become. If you look up a technology that Tektronix used in their oscilloscopes called New Color, that is the last incarnation probably of field sequential color. And they put several LCD films in front of a monochrome CRT and turned them on and off to make different colors. And so their scopes are dimmer, but noticeably sharper than their HP competitors of those periods.
And color broadcast from the moon.
Yes, they did take a color broadcast.
Give us a very brief.
Yeah, so there was the early color cameras that landed on the moon. They were field sequential colors, and apparently I think the data rate that was available from the moon to the Earth was apparently not very good at that time. So the frame rate looked pretty bad because whenever there was any motion in it, the color breakup was just enormous.
But they did it for the weight. They did it for the weight. They only wanted one Plumicon with a color wheel was lighter than 3 Plumicons back then.
Well, that sounds pretty crazy. Have things as complicated as possible. But they did land, and we did see the pictures. So that's great. Okay, let's switch over to the next talk. I'll be covering this topic of the Farnsworth GV-260, which is a set they came out with in 1947, one of the first ones on the market, along with the RCAs. And anyway, very early set. And we'll go into one particular circuit in there, which turned out to be quite interesting. It's called the beam relaxer, which they use for their horizontal deflection system. Okay, so this is the set that sort of got me interested in this whole topic. As I mentioned in the introductions, I do a lot of restorations for other people. One of those guys, Jerry, was going to be here today, but he kind of fell ill and couldn't come. He just notified me this morning that he couldn't make it. But last year, he brought this set. And I had already restored it at that point, but you wouldn't know it because he was trying to demonstrate it, and it didn't work, and it started to smell bad and various things. So he brought it back to me for a warranty repair, which I did, and you'll hear quite a bit about that. But anyway, these sets are really quite rare, and they're considered kind of very cool. This teardrop-shaped cabinet is quite attractive, and for a guy like me, what's interesting is that the circuitry inside is different than what everybody else was doing, because Farnsworth really sort of had his own television system developed, and of course they eventually converged on all the same thing, but for a while they made different choices on circuitry. This is just a little bit of the early advertising showing this set in a pretty interesting prototype set in the center with the clear cabinet. The other, I think this is the back side of that same brochure, just a couple interesting things that they were doing. If you can read what I circled there in red, the first is simply saying, incorporates the developments of 2 decades of continuous Farnsworth research in television reception, research that gave the world its first all-electronic television system. And of course, there's a lot of discussion still today about who really gets credit for inventing all-electronic color or all-electronic television. Farnsworth is certainly in the running. He did a lot. Whether he did more or less than other people, I'll leave that for lively discussions for others to have. But the next 2 circles I also found quite interesting. The second one there says, completely new 10-inch flat face picture tube provides brilliant, steady, high definition 52 square inch image, which can be viewed in full daylight. And that's highly related to the next circled thing, a mirror-backed picture tube extends tube life, greatly increases picture brilliance. And sure enough, this set has an aluminized picture tube, which in 1947, it might have been the very first one that used aluminized tube. I'm not sure. I did ask a little bit on the forums, and General Electric came in with a great big push on aluminized tubes in 1948 and 1949. So I'm not really sure if these guys were first or whether Farnsworth played some role in the development of aluminized tubes. I don't know, but it was just notable. So I don't know, and I didn't make a note of the manufacturer on the set I restored. Some of the discussions I had on some of the forums suggested it might have been Rowland, who had something called the Visitron in 1947, which was an aluminized 10FP4, which is exactly what this set has. So anyway, that's an interesting aside. I don't really know if they were first on that or not, but they were certainly very early to adopt that brighter picture tube, and it really does look better, of course. Now, the last little circled spot there is what I'm going to talk about in a bit more detail. Electronic beam relaxer results in simplicity of electrical circuit design, permits more economical set maintenance. The second half of that statement will turn out to be not true at all, which you'll see in great detail, but the idea was a good one. Just a few more eye candy shots here. I think these are really fun pictures. They made this lucite cabinet for one of the prototype sets, and they also made this thing on the right, which looks like it might be fiberglass or something, or who knows what. Maybe just stamped sheet metal into that shape. But they had a great stylist and made a pretty cool looking TV. And one more of those prototypes, a little bit different design. And then finally the set itself, which is a wooden cabinet, either blonde or mahogany. Okay, now they do have one of the prototype sets at the Early Television Foundation in Ohio. And so that you can see the picture of that. That would be one that was probably done in maybe 1944, 45, 46, somewhere in that time range. Looks like they were working on the tuner because there's holes cut in the side of it for, at the bottom, those little holes line up with the adjustment slugs in the tuner, and the upper ones are for the tubes. I'm not sure why they needed a slot in the cabinet for that, but they were obviously doing something with the tuner on that. Okay, so let's move on to this crazy circuit called the beam relaxer. And this is a little schematic of the horizontal deflection system. First, let me describe what it is, and then we'll get into the schematic a little bit. It's a free-running sawtooth oscillator. If you don't have any sync signal, it just keeps right on going, just like normal sets do. It is triggerable via incoming sync signals, and it has high enough current to drive a yoke and high voltage generation. And they do the whole works with one 6L6. And that's pretty interesting. So we're going to declutter this schematic so you can look at it in more detail. On the right is just the high voltage doubler for the high voltage. You won't be seeing that anymore once I cut this down. And those two lines going straight up from the 6L6 are the horizontal yoke connections. So, and then sync pulses in via that shielded cable coming in from the left. So now let's zero in on this a little bit. Well, first, a little bit of their own verbiage. We're not going to read all of this. I'll just talk about a little bit of it because it relates to what's going on here. The first paragraph, the beam relaxer horizontal oscillator is a product of Farnsworth Research Laboratories. Its features include simplicity, one tube, you got to give them that, that's pretty good, and dependable operation, combined oscillator and high voltage generator in one tube, lightweight and compactness. And here's a little the motivation, which makes some sense. Such circuits were employed during the war in airborne television equipment where these features are of paramount importance. So the impression I get from that paragraph is that they really did use this circuit without anything else on it to handle all of the horizontal deflection stuff in airborne receivers. Now, when we get to their actual product that they sold to consumers, they didn't. They added a whole bunch of stuff that destroyed this simplicity and low cost of this system, which you'll see. Now, the heart of the circuit is just this part where I've cut off all that other stuff. You see you can call it a flyback if you want. It's not really at all the same as a normal flyback. It's really a normal RF transformer. You see the primary is shown on the right because the 6L6 plate is going over the top and over to the right side. The high voltage secondary is just an auto transformer, so another tap on that. And you've got two sets of high voltage filaments there, so you can ignore those. A few other things. You've got well, notice first of all, the yoke connections go to that same secondary on the left side of the transformer. That's the yoke secondary and the grid secondary. So both of those roles are played by that. And if you bother to sort of trace the wiring from those two lines going upward to the yoke and down and around, you'll see they really do connect more or less directly across that yoke and grid secondary I've shown, with a little bit of a complication that you've got some of the cathode current being used for horizontal centering. Nothing really significant about that. You just want a little bit of DC plus or a little bit of DC minus current going through the yoke, and they found that the cathode circuit of that tube was a handy place to get that. You've got a few components there in the middle, which I just say are for improved linearity. I think you can believe that that's probably true. You put some inductors and resistors, capacitors, and it affects the waveform. Now, a couple other things. you've got sync pulses coming in via that shielded cable, and look where they go. They go to the screen grid. So that's kind of cool. A screen grid that's got a job to do, that's actually controlling something, not just shielding or whatever, you know, the other roles of that are. And then you've got a horizontal sync control, they call it, on the cathode, which is basically setting the cathode bias relative to the control grid. Okay, so anyway, you've got an idea of what's in that circuit. Now let's talk a little bit about how it works. And what you've got here is, well, first, if you look at on the left, if you don't have any sync pulses coming in, which is easy to do, you just pull out a tube in the sync separator and other circuitry that's feeding this thing, then you get this screen waveform that you see at the top left there. And I'm not going to go into the shape of that quite yet, but bottom line is, you know, when that voltage is very low, there's a ton of screen current flowing, and when that voltage is very high, there's no screen current flowing. What does the sync pulse do? It's a little negative going blip that simply gets impressed upon that. As you can see, there's a resistor coupling the screen to its DC supply, so you can wiggle that line if you've got this sync pulse coming in. And then on the cathode, you can see what's going on in terms of basically the yoke current is going to be proportional to what you see going on there. And you can see the current is ramping up during the forward trace, and it's going negative or down to zero during the retrace. And then look at the grid and yoke voltage in the upper right. And here, just a little reminder what's going on. You see that during the forward trace, it's sort of a small, relatively constant value. That's because of the LDI-dt going on there. The current is ramping up, but the voltage is staying roughly fixed. And, or I should say, sorry about that. It's actually the other way around. But then we've got the retrace is just a big negative pulse that's occurring at that. So if we want to see how this works, we go to the next page. And what's going on there is simply that the cathode is ramping up in voltage as that current increases, and then suddenly it gets too close to the grid voltage, and then that causes the tube to drop its conductance, and the current falls a bit in the yoke, which means that the voltage across the yoke actually flips sign. And since this is a positive feedback situation, that immediately turns the tube off, and it makes a very big negative grid voltage at that point. And the other thing that's interesting is what's going on with the synchronization. Well, in the upper left there, you see if you do impose that little negative blip on the screen voltage, that does cause the current to momentarily drop a little. And that's enough to set off the whole chain of events. That triggers, even if it hadn't gotten to the end of its trace, the current drops and the whole thing starts off with a big negative grid pulse and goes on. So this way you can see that it does free run, and it is triggerable, and it does it all in one tube, a 6L6, which is not a great choice for various reasons, but we'll talk about that in a moment. Now, one thing that's really interesting about this set, if you look at the prototype pictures, they have just one chassis, the way any engineer would lay this thing out. You'd make the chassis big enough to hold the circuitry that you need, and it would look nice and clean and intentional and so forth. But when you get to the shipping set a few years later, it's got a whole nother little chassis on stilts. And what's that? Well, it's the horizontal sync chassis. So this is very interesting. That circuit I just showed you looks like it should be triggerable from incoming sync pulses, and you could imagine from the sync separator, you could do things to the pulses to get them into that proper negative going blip. And probably that's what their airborne World War II systems actually did, because that was a very simple circuit. But for some reason, when it came time to ship the consumer set, they did not do that. They put in a sync chassis, and we'll see a little bit more about that. The middle picture is the picture of the set I was working on. I didn't really take a picture specifically of that chassis, but you can see it up on stilts to the right there. And then this one I borrowed from the early Television Foundation. They took a picture of that little chassis, and you can see sort of what's on there. The circuit that's in there is recognizable to people who have worked on lots of conventional TVs, all the usual stuff. It's got a horizontal oscillator. Sort of the painful, expensive way to do this is to use a 6AC7 reactance tube to change the frequency, and then a 6AL5 phase detector, nothing unusual there at all, to close that phase-locked loop and keep that 6K6 oscillator running in sync with the broadcast signal. And then various pulse shapers in that triout at the bottom, one of which, coaxes the waveform produced by this oscillator into the right kind of negative going pulses to move on to synchronize the beam relaxer. But why did they do all this stuff? I think it simply has to be the case that for some reason that beam relaxer circuit didn't really synchronize well enough. Must have been some jitter in it, or I don't know what the problem was. But you end up having sort of two synchronization controls on this set. One to get this thing locked, and then another one to get the beam relaxer locked to what's coming out of here. So that's kind of humorous. And you can imagine there's lots and lots of extra cost to making this extra little chassis, putting it on stilts, attaching it, all that extra circuitry that you can be pretty sure they did not intend to put in this TV originally. But something didn't work well enough, so they had to do that. And so just I think I talked about this at the beginning, the fact that it melted down at the CHRS event last year, and then I got it back for warranty repair. The problems I saw when I got it back were the following. It had arcing on the high voltage board, arcing within the high voltage transformer, and I fixed it by adding an insulator under the board and rewound the high voltage transformer. So that, yeah, I did actually, believe it or not. So this is kind of an interesting story. You can see some of the problems here. On the upper right of that board, you see a lot of fried phenolic. There's a lot of arcing going on from those high voltage rectifier sockets at the top and going through to the chassis and then sort of frying the phenolic so it gets worse and worse and it just won't insulate anymore. So that was kind of easy to fix. I tried a little Q-dope at first, but it didn't happen. You can believe that. So it has I made a plexiglass plate that I can put between that phenolic and the chassis, and that definitively solved that problem. But once I had that done, then the transformer itself was showing arcing and obviously getting worse and worse with time. It just sort of cooks itself to death. So what do? This is not a normal flyback. You're certainly not going to get one from somebody else with a different kind of set. Only Farnsworth uses this thing. So I looked at this and I go, wow, the mandrel's kind of nice. It's got this plastic mandrel and the number of turns is not very high. We'll talk about that. But what's going on with this core and so forth? So I was at a loss because, it looks like the core is a wound metal band with a clamp around it. And I thought, well, maybe you could unwind that band turn by turn. But that sounded like, what a mess. It's got a lot of glue on it, obviously. So what do? I went to the Antique Radio Forum and I asked some questions. And the cool thing is on these forums, there are smart people who know stuff that I don't. And so I showed that picture, and this guy from Australia, iRob2345, I don't know much about him, but he often posts on there, and he's got lots of deep technical knowledge, and he does a good job. He writes back, says, oh, that's a fairly typical C-core transformer. Just curious, any of you familiar with a typical C-core transformer? You are, okay. So, well, whatever. It's good to see that some of you know what that is. And he said, it's actually made in two halves. It's strapped together. They wind the core, and then they cut it with a saw. And once you can separate the bobbin and so on, from there you're in good shape. So I thought, oh, that's really interesting. If that's all true, I can do this. So sure enough, now when you look at the picture at the upper left, is there a seam there or not? And my conclusion is you cannot see the seam. They did a really good job of gluing that back together and clamping it, and that's why you have no clue that this thing comes apart. But if you do in fact just cut the clamp, as you see in that center picture, and work with it a little bit, sure enough, the thing comes apart in 2 chunks. And then you've got the mandrel free, and now you're in business. But this I would never have guessed without a little help from the internet. So yeah, I have a little coil winder, and I stripped the windings off of that core. It's a little bit deformed. You can see the plastic spacers there are kind of wavy. So it actually was a little difficult to get the windings off and the new ones on. But the good news is it's not a ton of windings, and with that mechanized winder, it's easy. So I rewound it. The primary is 2 layers of that pancake, 250 turns each, so 500, and the secondary for the high voltage is only another 300 turns. So quite different than the usual flybacks you're used to, which have, I don't know how many turns, but thousands, I would think, for that super tiny fine wire. This is nice and thick wire, 32 wire gauge, so very easy to work with. Gilles.
Tom, how did you count the turns? Did you do it manually?
Yeah, I counted them as I unwrapped it. Yeah, so that's not so hard, as long as you don't have any distractions, right? So yeah, it was possible to rewind this thing, and you can see the picture there where it's all back reinstalled with the new windings on it, and the new plexiglass spacer, which you probably can't really see there, but the phenolic board looks kind of thick, and that's why. And there's new tube sockets. I used porcelain tube sockets this time, which they should have done originally. It would have prevented this problem. And also the 6L6 socket is now porcelain. That had been a Bakelite or phenolic or whatever that is, and those tend to fry. I've only seen a few sets designed where the horizontal output tube is not a capped tube. This one and one Westinghouse from the early 50s or late 40s, and both of them have the same problem. There's arcing in the socket fries, and that's why it's not really a good idea to design your set that way. But that was done, and then the only other changes I needed to do to really bring this up to a good standard is to sort of optimize the sync separator and DC restorer, which I didn't have quite as tweaked as I wanted the previous year, and a little video and audio IF alignment touch-up. And after all that, then the set actually starts working just fine. And you can see a little bit here of the video. Won't bother with the sound, but what you can see, it's actually a very stable. There's no funny sync stuff going on there, no wavy lines. It just looks very good and solid. So that set is now working very well.
What sync controls were brought to the front panel?
So he asked what sync controls were brought to the front panel. So they have one that's called framing, but that we would call vertical hold. And that is all. There's 2 sync controls on the back, which is the horizontal frequency from that board on stilts. So it actually is a slug hanging off the back of that board. And then there is the little horizontal sync for the beam relaxer circuit down in the rear corner of the chassis as well. So you fiddle with those 2 to get sort of nice linearity and good synchronization.
Were they critical?
So actually, well, what I found is, like any set, you've got to get them adjusted right. So they're critical in that sense, but they're not touchy, and I don't have problem with it drifting and needing all kinds of fiddling while the set is running. So it seemed to be quite stable once it was all kind of put in place. All right, so I think that, oh yeah, there's one kind of funny final twist to the saga of the GV-260, and we learned a little bit about this last year. We had a visitor from Southern California, Richard Dean. He couldn't make it today. He had some health problem come up, otherwise he was going to join us today as well. And he had brought last year one of these cabinets from the Farnsworth. And just recently, I became aware of one of these things for sale somewhere in the foothills of California. And I almost bought it. They were trying to sell a whole bunch of Predictus, but in one corner of one picture of their Predictus, I could see, oh, that's a Farnsworth GV-260 cabinet. So I wrote to them and said, hey, I want that. I don't care about your Predictus. I want the Farnsworth set. And we even made a deal. I was going to go buy it and so forth. But then I started researching it, and I asked them to send me a full picture of that set, and it looked more like this one on the right. And you can see the knob pattern is all wrong. It's got 4 knobs on it. Says Farnsworth above the picture tube. So what's going on there? Anyway, Jerry eventually did buy the set. I didn't want it. If it wasn't the Farnsworth with its weird circuitry, I thought I'll let it go. But Jerry, who already had the Farnsworth GV-260, he wanted to buy that set. So what is that set? It says Farnsworth, but it's not. It's actually, I guess I should go back. It's actually Electromatic 101, which is a 1949 set. And Richard actually mentioned this last year. I just didn't make a big note of it because I thought it was some obscure factoid that I would never face in reality. And sure enough, a year later, the set comes up for sale here in the neighborhood. Electromatic 101. So if you go into Rider TV, there is in fact a page, or a set of pages for Electromatic 101 in 1949. And if you analyze its circuitry, it's completely conventional 1949, a normal flyback transformer, all kinds of stuff. There's not a stitch of Farnsworth chassis or circuitry in that set. It's really a totally independent manufacturer. All they did is they bought the cabinets. For some reason, Farnsworth stopped selling the GV-260 abruptly. And they had tons of cabinets left, and they sold them on the surplus market. Interesting to speculate what was going on with Farnsworth. Obviously, they never really made it as a major manufacturer. These sets are rare. Something was going wrong. To stop the production, even while you've got tons of parts already sitting in the warehouse, would suggest something like, they maybe were actually losing money. Maybe even the marginal profit was 0 on the sets, and the investors came in and said, don't sell a single another one of those, because every time you do, it's $10 out the door. I don't know what it was, but it had to be something that bad to get this company to stop suddenly. But you can see that it is a costly design. It's got that aluminized tube, it's got the nice beam relaxer, but then a whole other sync circuit on top of it. A lot of low volume parts that are unique to Farnsworth, so they didn't have the economy of scale. So anyway, they sold these cabinets to surplus, and on the ETF website you can find some examples of these. You can't match these mid-America values, only $24.95 for that cabinet, but you can definitely beat them if you buy them someplace else in 1950 for only $5.95 for the. So there had to be a lot of those, and they didn't know what to do with them. So Electromatic decided to buy Farnsworth cabinets and make their own set inside. So I think that's just a weird story. Like I say, Richard did already clue us into that whole thing last year, but it's real. The sets are out there and you can find them. So with that, I will conclude.
I have a question. How long was Electromatic in business? Oh, excuse me. How long was Electromatic in business?
So I don't know that the literal answer to that question, but it couldn't have been very long because there's only the Electromatic 101. There are no other Electromatic sets, and the sets are not very common. I mean, this is one real one in the flesh. The ETF in Ohio, I think, has one, and I know of no others offhand, but they're out there in small volumes, probably even smaller than Farnsworth. So. They're not common. Any other questions or comments?
You didn't mention this, so I suspect your set doesn't have it, but Farnsworth also sold TVs with a polarizing coating on the CRT they called a Polartron, in addition to aluminizing. Did your set have that?
I don't think so.
Okay, it may have come in next year or something, but they definitely made 12-inch ones that, again, they had a label on them that said Polartron, and it was a polarizing thing that was supposed to give better contrast, and then it went away.
So that's pretty interesting. I've never heard of that. You said 12-inch. This, of course, is 10-inch here.
No, but I'm saying I actually have a 12-inch. I have a 12-inch one, a CRT.
CRT only.
CRT only.
Yep, but it's got the polarizer.
But it's got the polarizer.
Yeah.
And it's basically like they dunked the whole tube into some kind of plastic. It's a scratchable plastic coating.
Well, it's interesting. I mean, you don't usually get polarization for free by any kind of dipping process like that. So they did something special. Yeah. Now, of course, tinting the glass, that was an easy solution, and a lot of people did that. And if you combine tinting with aluminization, you get a really nice contrast on a black and white tube. So a lot of that was done. But this is the only time I've heard about polarization.
And again, the label on the tube says Farnsworth Polartron, and it did definitely come out of a TV.
Farnsworth Polartron. Okay, I'll have to look that one up, or maybe ask on the forum if anybody knows what that is. You wanted to make it?
Yeah, I think correct me, but I think I remember Munce had a single tube horizontal system at some point.
I was going to comment on that. Yes,
You go ahead, Kurt.
It was I think. Yeah, Munce had a single tube horizontal oscillator that kind of looked like that, if I remember correctly. And the Munce TVs were not known for their longevity or their high performance. They had fewer parts in them than probably any other TV. I heard they were not because they had so few parts. And in fact, I think it was Admiral made an ad campaign about parts that aren't there can't go bad, and then they disproved their own statement with a lack of reliability.
Yeah, there had to be something wrong with Munce sets because they also didn't last long. So I don't know what, but anyway, that's interesting. I'll have to look that up. I can research a little bit the Munce circuitry and see whether they had something very similar or whether they had really something rather novel of their own.
Yeah, it was a single tube oscillator horizontal output.
Yep.
I just have one more comment. I recently saw on the ETF site a 27-inch Munce TV that they got, and that surprised me. So it was a low-cost TV, so I guess they just had to cater to the person that wants a larger screen.
Yeah. Maybe they had the cheapest 27-inch set. I don't know. All right. Okay. I guess there's one more comment or question.
Oh, just going back to one of the first screens, I really like the use of the language high definition in combination with the 1949 set. Had I not seen the original advertisement, I would have thought it's an anachronism. But I just thought it was interesting.
I suppose, yeah, as Kurt was pointing out, high definition is all relative, and what they had before then was lower. So I do see that term from time to time in the literature from that era where they're calling these sets high definition. And of course that term was recycled very, very nicely again in the early 2000s. All right, so that'll bring our morning session to a conclusion. Okay, welcome back to our afternoon session. You can see we've got Fred Deal coming up first with the showing of the Real McCoys. He's also going to say some words before that rolls. And I'll follow that with a little talk on the restoration of that set in the back together with Nat. And then the break, and then John will come back with a little bit more on color. If we have a theme this year, it's color TV, right? We've got a number of talks on that. Over lunch, a couple of us were talking about what a technical marvel the introduction of color TV was in its day. Much more so than just black and white TV. That was already quite an accomplishment. But color it's just mind-boggling what they pulled off with the technology they had in the short period of time that they had. Too bad that nobody wanted to buy it, but so that'll be Nat's story in the last presentation there about early color programming. Okay, so with that, I'm going to turn the mic over to Fred, and you can say a few words while we get the show set up to run, and then we'll run it when you're ready.
Okay, great. Oops, too close to the speaker. Well, I thank you very much for what you're doing here, having this group, and I appreciate the group because I learn a whole lot when I come here. And so my story starts when I was about, 4 or 5 years old. We had a neighbor, we lived in Oroville, and I went over to their house, and we had a 21-inch Hoffman TV, okay. Went over there, and I saw this set on a table. I thought, what, you know? And I asked my mother, why is that screen so small? She had nothing to say about it that I remember. But anyway, that got me interested. I said, I'm going to find out what those are. And of course, I didn't because, too young. So the next year, we went over there and we visited them. The set was gone. They bought a new one. I said, what'd you do with the television? And they said, it's in the closet in the back room. So I went back there and I could see in the back, I saw the back of the CRT and the tubes, whatever. I didn't know what I was looking at. And I said, can I have it? I usually wanted interesting things. So no toys, but interesting things. So they said, no, we're going to have it fixed. Okay, well, fast forward to 1959, and we watched the Real McCoys. It's a pretty good show, actually. And when it came on and I saw that Hallicrafters, I went through the ceiling. I said, Mom, I got to have that set. That's so cool. And I obsessed over it. So that went on for a while. And then fast forward another 20 years, and I joined the radio club around 1980. And Don Steger was the president. I don't know if you know him, but he had Vintage Sound in Sacramento. He was the president for a long time. And I said, Don, do you know anybody that has a Hallicrafters TV? He said, yeah, I've got one. So, but he said it needs some work. So I went over to his house and I saw it. And he had already made a rubber mask for it, for the tube. And I did not plug it in, but so I had an Admiral that had a 7-inch Admiral that had, instead of the lattice work grill, it had 3 squares, and he said he'd never saw one like that before. I said, well, would you trade that for Hallicrafters? He said, sure. So he did, and I got it home, pulled the chassis, and the first thing I saw was a bus bar running from one end to the other, and the paper caps they had replaced with Mylars were hanging off of this for ground. I thought, what the heck is that? So I looked at each end to see how it was soldered, and it wasn't even, the solder joints were no good. So I can imagine how that set must have worked. So I straightened that up, and then I looked around at all the components, and I saw that someone had put an extra resistor in series with focus control. I thought, all right, so I'm going to take it off, and I tested the resistor with a meter that was in there. Well, it was good, so I put it back on, said, okay, fine. But in the meantime, before that, when I got it working, after that, well, I put a cover on the high voltage cage that was missing. So when I got it working, I thought, well, when I got it working, let's see. I got it working, and then I had to, there was a problem with the linearity, and there was a problem with the picture drifting. So I thought it's got to be those ceramic capacitors in there. So I changed those and put film capacitors in there. That straightened that out, and it's been working fine ever since. So that's my story of that, and I was so happy to have it now. And and there is one in the back. Of course, you guys can all see it. I did not bring mine because I didn't want to carry it up and down the stairs. So anyway, and I have another story to tell, and this is very short. I had a lady friend, and she told me there was a radio at the Veterans Thrift Store in West Sacramento. Okay, so I walked in there, and at high school I saw this book, because I was always perusing interesting books there in the library at Placer High, and I realized that was a television. I almost went through the floor. I said, that's a pre-war television, holy cow. So I walked up to it, and it had a broken grill bar in the bottom, and I lifted up the lid, and I looked, and someone had taken the TV set all the way out and put a turntable in. I mean, that was horrible. So I told Don Steger about it. He bought it, put it in his shop. He had the violin maker make a grill bar for the bottom, made a perfect job of it, and he sat there for years. And then Kurt Swanson kept wanting to buy it, and finally he did. And then he had it in his place for a while, and he found a collector in the Midwest that had a chassis and a picture tube, but the high voltage power supply was missing. So this guy bought it and took it back there. He said he has to make a mask for it and all this. And so I assume that he's got it all working if he found a high voltage supply, but he could always make something in lieu of having the original. So it's probably working now. So that's the story of the TRK-12 that made the rounds. So anyway, that's my story, and I'm sticking to it, and I hope you enjoy the Real McCoys. The television set, it's really a good show. And I do have a film in my collection, and this is just very quick. Next year, that maybe I could bring the projector and screen just for the heck of it and run it. It's a 1954 film that features a 3-inch pilot, which we all have too. So if that's okay, that would be fine. Anyway, thank you so much. Appreciate it. And I enjoy the show.
Yeah. Yeah, thank you, Fred. Sure.
For you. Really? It's the story of the TV Guide article about the Real McCoys and Brennan.
All right, so Nat has just given them the TV guide that talks about this show series. You know, we often have a lot of technical presentations, and that's sort of the bread and butter of our events, but we try to include the other aspects of the history of the television. For example, like Nat later today will talk a lot about color programming in the early years. Once in a while we have talk about manufacturers and so forth. But this is sort of a new thing for us. Reliving what it was like to watch the shows of this time. And this one's doubly fun because it happens to be about a television set, and the set is indeed the Hallicrafters, of which we have one back there.
Picture myself on the screen.
No. So, somehow I didn't get that. So, but anyway, we'll run the show now and enjoy.
The Real McCoys, starring Walter Brennan, created by Irving Pincus.
Want you to meet the family known as the Real McCoys. That's Grandpappy Amos, the head of the clan. He roars like a lion, but he's gentle as a lamb. And now here's Luke, who beams with joy since he made Miss Luke McCoy. From West Virginia they came to stay in sunny California. Old Grandpappy Amos and the girls and the boys of the family known as the Real McCoys.
Except maybe an apple box to sit on. Hope you enjoyed the show.
Yeah, I thought it was real keen. It was even better than last week's.
I'm sorry to have to turn off the picture, but I'm getting ready to close.
Oh, we want to thank you. We'll probably be seeing you next Thursday night.
You folks sure like television. You ever thought of buying a set?
Oh, yeah. There's only one thing stopping us.
What's that? Do you live in a fringe area?
No, a poor area. I'm afraid we just don't have the money.
Oh, now television sets aren't that expensive. Any family with an average income can afford one.
Yeah, well, if our income ever gets average, we'll stop by and see you.
Oh, gee. Now, little Luke, we'll get a television set sometime, as soon as we can afford it.
What about the $15 from the billboard company for letting them put up their sign?
Oh, little Luke, don't be silly. We couldn't buy a set for that.
Oh, yes, you could. This one right over here. I've got it in the window for display, showing one of the first TV sets. You only go back to the storeroom. You can have it for $15.
You mean we could have that one?
That's right.
Oh, boy! I think we ought to buy it. Me too.
And now, wait a minute, everybody.
The set works well. I'll guarantee that.
Oh, it's not that. It's just, well, where this much money is concerned, everybody in the family has to have a say-so. And, well, there's one member we haven't even talked to yet, Luke.
Well, you leave Grandpa to me. I'll just tell him how much we all want it.
But, Luke...
Now, just let me handle it. Mister, we'll be back tomorrow night after supper with the money for you.
Fine, I'll expect you.
Good. Good night. Night, thanks.
Golly, we got a television set. We'll be all a big show. Yeah, when I come home with a bad report card, I'll have a good excuse like all the other kids.
It's a view,
We can put the television set on this table, right over there. Okay.
I can hardly wait.
Me too. Luke, turn Grandpa's chair around so he can see real good, huh?
Grandpa will be able to see it fine from here.
Well, I'm going to sit right here.
Oh, no, you're not. You ruin your eyes sitting that close.
Yeah, you're liable to fog up the screen with your breathing. Must be Grandpa. Wait, he gonna be surprised.
Well, where is everybody? Oh, there you are. See, I got some great news.
Grandpa, wait.
Not right now, little Luke. I got something important I want to say. Now, what is it we've all been wanting more than anything else in the world?
A television set.
Of course not. A power saw. Sam Watkins got a humdinger. He's willing to sell it to us real cheap. The money we got from that billboard will pay for two. Well, what's the matter with everybody? Didn't you hear what I said?
Yeah, well, to tell the truth, Grandpa, we was thinking of using that money for something special.
Well, this is special. Now, you take that pile of firewood out by the barn. Why, with that saw, we'd zip through it just like nothing ain't all.
Yeah, well, wait a minute, Grandpa. We got something to say to you.
I'm monkeying with my chair here.
Yeah, well, Grandpa, listen now. All of us, we been kind of talking things over, and we decided...
We're getting a television. We're getting it tomorrow.
I hear what that innocent child just said. Before I wash his mouth out with soap, I want one of you to tell me that it ain't so.
No, it's the truth, Grandpa. We already talked to the man, and we made us a deal.
Why, you can't do that. I done give Sam $5 deposit on the saw. He's bringing it over tomorrow.
Well, for gosh sake, Grandpa, you could have told us first. We all want to spend that money for a television.
Well, I ain't going to allow it. Not when I get a chance to buy a power saw that's in A1 condition.
Gee, Grandpa.
Why, that's pure foolishness. Squatting in front of a little black box all day, staring bleary-eyed at people who ain't more than 2 inches high.
Grandpa, how can you say that?
Oh, in no time at all. They'll disappear like buggy whips in high-button shoes.
Now, look, Grandpa, it's getting downright embarrassing being the only folks in this community that ain't got a TV set. Well, many's the time I thought of putting an antenna up on our roof just for appearance sake.
We know a power saw's more practical, but, well, there's times when a person's got to do things just for pure pleasure.
We ain't got no time for pleasure. We got to spend all that time scratching the ground to get a living.
Well, I was hoping it wouldn't come to this, but you got to remember, Grandpa, this ain't your money. It belongs to all of us. I can see we got to put this up to a family vote.
Now, wait a minute.
And you got to remember that that's binding on all us McCoys.
I can tell by looking at all of you. I get as much chance in this vote as a worm has in a hen house.
There's 2 sides to everything, Grandpa.
Well, I'm on the side that's right. Go ahead and take your vote.
Well, we're just trying to do what's fair, Grandpa.
All right. But first, I want you to all stop for 10 seconds and think over this terrible thing you're doing. Time's up.
All right. All those that want to use the cookie jar money to buy a television, raise your hand. Grandpa.
Buenos días, señor Grandpa.
Here you are, Grandpa.
Well, now, look, Grandpa, this ain't no way to act. I mean, just 'cause we all voted against you yesterday, it's all over and done with now. Let's shake hands. Well, now, doggone it, Grandpa, you can't go on like this forever. Sooner or later, you gotta talk to us. Even if it's only to ask for the sugar.
Should I fix the fence this morning, señor Grandpa?
Well, Grandpa, do you want Peppino to fix the fence this morning or not?
Well, in that case, I think I'll take the day off. I think I'll fix the fence.
All right, suit yourself, Grandpa. But all your life, you've been blowing off steam. If you keep this bottle up inside you, you're going to explode.
Can I fix you some eggs, Grandpa?
Say, I was listening to one of them college experts on the radio last night. Did you hear him, Peppino?
Oh, sure I heard him. What did he say?
Well, he was saying that the small farmer can't compete with them big fellas no more. No, it just ain't economical. It's kind of a shame to see it happening.
Yes, yes. I guess the small farm must go.
You pass the toast, will you, Peppino? Yeah. Well, the handwriting's on the wall. The way things are going, I guess we'll just have to sell the farm for whatever we can get.
Oh, I don't think we could get much for this farm. It's in very bad shape.
You know, it might be kind of interesting moving into the city. We could all get jobs at the factory.
Oh, Luke, why don't we just give up and let Grandpa have his old power saw?
No siree, Bob. We took a vote fair and square, and I'm abiding by it. I can be just as ornery as he is.
Senor Grandpa is a very stubborn man. Bad temper. Hard to get along with.
But he sure makes good eggs.
Hi, Sam.
How you getting along?
How are you?
Oh, say, I got it right here for you. Look at that. Ain't she a beaut?
Yeah.
I got her all oiled and tuned up. Yes, sir. Once you get going with a tool like this, the air will be so thick with sawdust, the birds will have to stop flying and start walking. Huh, Evers?
Sam,
Now, you just give me the $15 you owe me, and the saw is yours.
Sam, there's something I gotta tell you.
Why, you'll have that pile of logs over there sawed up in no time at all.
Maybe I ought to watch you cut a branch or two, just so as I get the hang of it.
Sure, okay.
Right. You'd sure like to see it work. But you've been working for some time, you'll know more about it than I do.
What do you think of that?
I'm pretty slow catching on to things. Maybe you better do a little more.
Look, I ain't gonna saw up that whole pile of wood for you. You just give me the money.
Well, now, I'm sorry, Sam, but I'm afraid the deal's off.
You mean I got to go all the way back to town and find me another customer?
Now, don't go flying off the handle.
Are you going to buy this saw, Amos, or ain't you?
Look, Sam, I want that saw worse than I want a lifetime pass to the county fair, but I just can't.
You're making an awful mistake, Amos. You ain't ever in all your life going to get an opportunity like this again.
I know opportunity knocks but once and hardly ever knocks around here.
So long, Amos. When you get to sweating and straining over that pile of logs over there, you're going to be awful gosh almighty sorry you ever let that saw slip through your fingers.
I know, it's just a torture me to think about it. Let go, Amos. I can't. My brain shot me let go. My fingers don't pay no mind. Sam, I've got to have that saw.
Amos, is it a deal or ain't it?
You get out and unload that tool out of that truck there now. Go in the house and unload the cookie jar. I know I'm nothing but a poor, weak, miserable sinner. But once I get that power saw, I'll have a lot more strength to repent.
Oh, shucks, Grandpa. You didn't have to do all that hard work. I would have done it. Here, let me give you a hand. Must be heavy. Well, that's a mighty clean job of sawing. Maybe too clean for hand sawing.
What is it, Lou?
Well, I ain't sure. But there's something we better look into.
What happened to the money?
Well, ask Grandpa. I think he's ready to talk now.
Of course I took that money. Anybody can tell me where I done wrong? Go right ahead. Shows a heap more sense to put our money into something practical. Don't you worry. You're going to get your television set someday. You know, little Luke, it ain't everybody can learn how to handle a power saw. But I'm confident that a bright boy like you, why, I can show you in no time. Why, I'll go through them logs, zip, zip, zip. Television set would come in mighty handy right now. Sure would like to hear someone say something. Even if they was only 2 inches high. Well, where you been? It took you long enough. Now, hot biscuits. Where's the butter? I forgot. Biscuits without butter's like a potato without salt. Sorry. I guess it don't make no difference between anyways. I'm going to have to get used to eating these cold meals out here in the barn with the rest of the animals.
But, Senor Grandpa, you could be in the house having supper with everybody else.
Sitting there with all them accusing eyes staring at me? Well, that's enough to spoil a man's appetite.
I guess maybe you're too touchy.
I guess I'll wait out here till they all gets to bed. There's a couple hours yet.
What does the writing say inside the case?
Careful now. This ain't no ordinary timepiece.
Well, I'll be careful.
To my son from his loving father,
May the 5th, 1860.
Well, you look pretty good for a man must be. That date don't mean me, idiot. It's my grandpa's watch. He done give it to my pa, and my pa done give it to me.
Chihuahua! It's almost 100 years old.
Yes, I'm going to pass it on to Luke. Provided we're talking by that time.
Grandpa, why don't you go in the house and apologize?
I ain't got nothing to apologize for. But there was a vote and you lost. That don't make no difference. They was voting for foolishness. I suppose you know why they done it.
Because they want a television.
No. Because they're young and they don't know no better.
Well, Senor Grandpa, maybe you have forgotten how it is to be young.
I ain't that old. I remember every gall-darn thing that happened to me when I was their age.
You?
Yes, sir. I remember taking a girl to the Monroe County Fair. Spent nigh on to $5 that day.
$5, huh?
Yes, sir. Stuffing ourselves with cotton candy and sarsaparilla and winning them Cupid dolls and all that foolishness.
It sounds like you had a wonderful time. Tell me, was she pretty?
Yes, she sure was. She had on a green calico dress. Green ribbon in her hair, too. I remember that because it fell off when I kissed her out in back of the palm reading tent.
She must have liked you very much.
Yeah, another thing I done the first year I was married. I walked right into a store and bought my wife a solid gold locket, just like that. Cost me $10.
Was it her birthday?
No, it wasn't nothing. I've been trying to figure out to this day why I'd done something so foolish.
Oh, Senor Grandpa, I don't think it's foolish to spend your money to make people happy.
Oh, what did I get to show for it?
You got some very nice memories. Yeah, I can picture Luke and Kate years from now talking about their memories and the beautiful, wonderful, exciting power saw that their grandpa bought for themselves.
You know what's a funny thing? I used to look forward to a long, quiet evening. Now, since we've been expecting to have a TV set, well, things seem kind of dull.
I know, Luke. I got a whole basket full of darning in there. I just don't feel up to it.
Yeah, well, if it wasn't for Grandpa, right now we'd be watching that show with them private eye fellas. You know, I can almost hear the music from that show right now.
I hear it, too.
What's going on?
Regretting it already. Hey, Peter!
What is it, Senor Grandpa?
I ain't getting no picture. Turn the antenna again.
Okay. We sure do want to thank you, Grandpa.
I know what it meant to you to sell your power saw so we could have this.
I never did know such a thing. Power saw's out in the barn where she belongs.
You got a picture now, Senor Grandpa?
No! It's like taking the goddamn contraption, tearing the innards out of it, and use it for incubator.
Let me try, Grandpa.
Hey, Grandpa, just where did you get the money to buy this?
Never you mind. I got ways.
Maybe I can still see A Tale of Two Cities. What time is it, Grandpa?
What happened to your watch?
Maybe it's being repaired.
And maybe you sold it to buy the television set.
No, I never sold it. I borrowed on it.
You mean you pawned that beautiful watch, Grandpa?
Well, it don't make no difference. Anything to keep peace in the family.
I'll get it back for you, Grandpa.
Don't you worry about it now.
No, I mean it. Homer Peabody heard about us having that power saw, and he called up and offered me $1 an hour to cut up some logs for him.
Oh, Luke, you go see Homer first thing in the morning.
Yeah, I'm happy to, because someday that watch is going to be yours.
No,
like
Grandpa.
A Tale of Two Cities. Grandpa, make him change to Channel 7.
I will not. I want to watch Pinker's Kid.
And I think you should watch what the grown-ups want to watch for the first night.
Yeah, that's right. There's one of them private eyes on.
We can watch one of those
A
anytime.
Tale of Two Cities will be on again.
Well, I want to watch Pinker's
Grandpa?
Kid.
Ain't it wonderful?
Wonderful.
Sure. To have a TV set and be able to squabble over it like every other normal American family.
Okay. So that was a fun show to take a look at for a while. Hopefully a good break to the day. Any comments or observations before we move on to next thing? Gilles?
Can we have a copy for our head end?
Sure. This copy I copied off of YouTube last night, and it's on my file, so if you want it, no problem. I'm not quite sure about all the copyright issues, but I'm not going to worry about that. Yeah. Okay. All right. So I think next on the agenda, so I'm going to talk about the restoration of the 1939 GE set together with Nat. And I think, Nat, you get to start it off. I'll get the presentation going, and it's got the particular ad that you're interested in there.
Okay. In the slideshow, do you have the advertisement for it?
Yeah, that's
okay. Yeah. All right. Yeah, because no one's ever been able to find out what the original retail price was on GE's line of televisions before the war. RCA, very clear, they put it in the ad, what they were going for. But I would say it's a couple months of work or more in labor, talking about buying TV sets and chainsaws and things. That TV was probably around $300 to $350 maybe in the dollars of 1939. So you can look at the size of that screen, it's even smaller than the one the Real McCoys had. That's a 5-inch set. It came from a friend that I bought it from. He lives in Arkansas, okay? And then he got it from somebody who lived in Connecticut, and that person found it in a junk shop / antique store. He found the chassis first and then scoured the antique store. No, he found the cabinet first, and then he scoured the antique store and found the chassis. It gets the low band of VHF, in other words, channels. It could be tuned to be, today, channels 2 to 6. There's 3 buttons, so it got 3 channels. Depending where you lived, that was New York City had 3 channels, and the handful of cities that had television back then probably only had 1, maybe 2. Okay, so like Los Angeles had 2 TV stations before the end of the war, Second World War. Chicago had 2 at the most, and usually they weren't transmitting at the same time. New York was the only place that had 3. Philadelphia, near where I grew up, we had 1 that was run by Philco, and you might have seen some Philco radios around here. And GE, that made the set, had a TV station in Schenectady, New York. So the thing was made, and the TV was manufactured in Schenectady, New York. And they had a TV station, WRGB. It's still on the air. I think it's CBS now. And it's up in Schenectady. So that was their 1 TV station. They started with 4 hours a week. And before the war started, they got it up to 20 hours a week of programming. So that's sort of the background for anybody not familiar with the early days, very early days of TV. And maybe we'll talk a little bit more about the technical aspect of how they changed the standards of television again in 1941 and then again after the war. There were some adjustments to the standards, but they weren't so severe that the TV doesn't operate. The TV can work, and we're going to fire it up as well. I'm not sure when we fire it up. Right after this talk. Right now? After the talk. Right after the talk. Okay, we'll turn the small TV on after the talk.
Okay. Yeah, it's not working perfectly, but I think it's working well enough. You'll get the general idea of how those go. Okay, so talking about the restoration of this set, here I just grabbed this off the Early Television Foundation website, giving some of the stats, the tube list and so forth, the channel frequencies that you can set it up for, the IF frequencies and so forth. So that's all there. The thing at the bottom I circled, for whatever reason, they had listed 2500 volts as the CRT anode voltage. And Nat, you had also mentioned that you saw that number somewhere. I don't know if it was here. But the set doesn't actually produce that, and the filter capacitors on the high voltage are rated at 2000. Maybe GE ran 2,000 volt capacitors at 2,500 volts, but I doubt it. So I'm guessing that that's probably a mistake. The chassis, if you pull it out, and this is the same thing you can see if you just look in the back of the set, you can see the 5 BP4 CRT with its 30-degree deflection angle, or maybe even less than that. And interesting thing about this particular set is on the left side of the chassis, there are 3 additions that are not original. I see sort of 2 octal tube sockets to the front and then some kind of special socket in the back. And I'll just address that for a moment because I think we figured out what was going on there. If you look on the inside of the chassis by those tube sockets, there's a penciled in tube name there. One of them is 6H6, and that's a dual diode, if you know what that is. And the other one is 6SJ7, which is sort of a multi-purpose pentode, and could be used in all kinds of amplification purposes, either IF or even audio if you wanted to. So I'm going to speculate that this was probably an FM demodulator just because of that 6H6 sitting there. Also penciled in on the back of the set chassis, it does say something, you can't read it that well, but it's something along the lines of change 1944. And apparently somebody knew what change meant, and probably that meant that this FM circuit was added at that time. Now, when Nat received the set and we started working on it, this had already been defeated and mostly removed. You see there's very few wires on those tube sockets, just a few things they hadn't bothered to cut off. So whatever it was, it went in at one time and it came out later. I think probably somebody who was trying to restore the set more recently probably wasn't quite sure what to do with that. And the whole AM detector audio section was sort of a hodgepodge of non-original wiring, so I think it was sort of put back sort of the way it had been before that was put in. Okay, so we get this set in and we do sort of an initial diagnosis of it. It had some broken and sloppy wiring that we fixed, probably just wear and tear from getting transported all over the country. I noted that the electrolytics had already been replaced, and as I studied it later, they'd been replaced twice already before we got the set. But the new ones were relatively recent Nichicon, something from at least the 1970s or sooner. So we thought it's safe to power this up and try it out. So we put it on a Variac, and sure enough, the B plus went up to 350 volts, which is fine. And the high voltage went up to about 2,000 volts, and that also looked fine. And we put the 5EB4 in and got a horizontal bright line. And so the vertical deflection wasn't working, and had sort of a faint audio on channel 3 after cleaning the tuner contacts, maybe a little fine tuning and so forth. And all the tubes were good. So at this point we thought, well, this set is definitely recoverable. It's kind of close to working as is. And so we set out to begin the restoration process. And of course, one of the first things you want to do is just get all those paper capacitors out of there. And Nat wanted this set restuffed. In other words, keep all the old paper capacitors and hide the new yellow caps inside them. It's not my favorite thing to do, and I never do it on my own sets, but for other people, we do it if they beg, and Nat properly begged in some way. So as we pull the caps out, we label them what they are, and I had taken a picture of the original arrangement of them all so we can put it back later. And then the new yellow caps, though, I'm just going to tack them in. They're just sort of, I don't cut the wires or anything. I just sort of tack them in. And that's not necessarily ideal for the RF and IF circuits, but it worked well enough. And then at that point, we tried again. So I had a faint raster, no audio. Actually went backwards on that. And problems that we found and fixed. Well, there was a mixer cap grid wire broken, so that got us some signal back through the set. I probably broke that just while handling things. Miswired cap in that hodgepodge of wiring in the audio circuitry, so I fixed that, and then aligned the audio IF as sort of the best you can for FM slope detection. And that was working reasonably well. So the sound is okay, but the video seems to be oscillating. It looked like this was an IF oscillation that was going on or something. I wasn't quite exactly sure. So we had these vertical lines and no hint whatsoever of any proper video coming through at all, really. So I thought, well, we'll get in there and try to get the signals through. So I'm injecting signals from the B&K analyst at various points back through the IF. And it's clear that the IF is just very unhappy. It doesn't really work at all. And so I thought, well, I've done lots of TV IF alignments. We can just do this. And I get in there and start working with it, and I see the target pass bands from Ryder. They're right in the middle of the bottom there. And I go, oh, we should be able to make that. And I put the sweep generator on there and the scope and so forth. And it doesn't look anything like that. It doesn't look anything like what I showed you in the lower right, which is after we aligned it. It was probably oscillating for some nice big spikes and various problems. And undeterred, we looked at it and said, well, we can still align this. Usually that works out fine. But I discovered that the IF transformers in this set are not typical at all of a post-war set. If you notice on the left there, a T7, and then, or maybe, yeah, T7 it seems to say, T3, and then T4 and T5. Three of those have no capacitors across the coils. So there's some kind of sort of self-resonant, pretty low Q situation. And what I generally found is that turning the slugs on those transformers had very little effect. Just a little bit of a slight nudge to the passband transfer curve. And all the action is on T4, and specifically on that one slug that tunes the coil that connects the primary and the secondary there. And with sufficient trial and error, I was able to get a passband that looked pretty good. On the right there, you see on my scope with the sweep generator, and I've labeled the tick marks as 10, 11, 12, and 13 megahertz. And yeah, we got it reasonably good, and I also chose to extend it a little bit towards the low frequency end, hoping to get a little sharper picture than it was originally designed to deliver. And that worked well enough. It was not possible to really get it flat at any bandwidth, but it in fact worked. So we fire up the set, and we're momentarily pretty happy, actually. That's actually not a bad picture on this set. And I probably fiddled with it for about a half hour to an hour, and then I heard something. Gurgle, gurgle, gurgle. And I go, ooh, that sounds bad. and then I can smell it too. And it's the power transformer that's cooking away. So I reach back and grab that and I go, oh, that is really hot. So the set was actually working fine, but it clearly had some kind of massive load on the power transformer that's generating a great deal of heat. And so you do what you do then. You disconnect everything. You pull rectifier tubes out and various things. And eventually I disconnected every single thing from the power transformer except the primary. And then it was still drawing half an amp. So that's 60 watts. And that pretty much explains how it got pretty hot in a half hour or an hour. So what do you do? And by the way, just noting, I didn't do this. There were plenty of tar drippings under the chassis as well. And that tells me that, in fact, this set had that problem already some time ago. Maybe even the guy that sold it to you might have even known that. So,
You never saw it working.
oh, well, the guy who sold it to him then, I don't know. Yeah, so we pulled the power transformer off, and we looked through the junk box, and I'll come back to the topic of, should we try to rewind it or whatnot. But at least for round one, I was going to say, let's substitute it. And we found, I should really show the next slide first, but anyway, we'll get to that. The power transformer from a Huffman 154 set was the best match that I had. And if you look at what you need, of course, you've got a 120 volt primary. It's got actually 2 filament windings for 6.3 volts. It's got the 5 volts for the 5U4 B plus rectifier, and about 600 center tapped for the B plus generation, 2 volt filament for the 2X2 high voltage rectifier, and something like a 1600 volt high voltage winding. I never measured that directly, but it's going to be somewhere in that range to give you about 2 kilovolts of DC for the picture tube. And of course, you cannot find a transformer like that for the life of you. It's not going to happen. So we talked a little bit about rewinding, and Nat may know somebody who can rewind that transformer, and you do have it, so you have that option to do that someday. But it'll be expensive, and it'll take a long time, and maybe you do it, maybe you don't.
You can't even tell, except that there's probably like 1 millimeter worth of difference. The Hoffman transporter that Tom put in there is almost the same size, and it physically looks the same, and you'll never know that it's been replaced unless someone tells you. So keeping the old transformer as sort of a backup and just keeping it is a good idea, but I don't think I'm going to rewind it because it's just a lot of headache. And also, you can touch the top of the chassis because that 2x2 tube is not running, and it won't destroy you, won't kill you. So the only way you can die with this set is reaching under the chassis when it's operating. That's not going to happen because it's bolted down. So it's now a safe TV.
Give or take a few CRT wires that I wouldn't mess with too much. So anyway, what do you do? We selected this Huffman transformer to supply everything except those last 2 items. It's a pretty good match, but the B+ winding's a little high. I did add a power resistor under the chassis to bring the B+ back to where it's supposed to be. And what do we do for the high voltage? Well, we do have about 800 volts worth of B+ windings on the set, and it's not so far to get from 800 to 2 kilovolts. So we made a voltage multiplier, and we made the full wave version of it, the so-called Cockcroft-Walton design of a voltage multiplier. And although that diagram at the top shows you can make as many stages of that as you want, and go to arbitrarily high voltages as long as you don't need much current. Here we only need 4 times, and since it's a full wave rectifier, we actually only need 2 stages of that because you get 2 times the plus and 2 times the minus. And so we actually built that just with parts I had on hand. I didn't happen to have any high voltage capacitors, so you see that there are pairs of 600 volt caps there with dividing resistors and so forth. But it actually otherwise more or less follows what you see directly above it there in terms of the circuit. And you put it on the high voltage probe, and yeah, it produces 2 kilovolts just fine. And put that into the set, and sure enough, we're back to operation. And there's the picture on it, running with that voltage multiplier just sitting on the bench, just to kind of try it out, see if this concept is really going to work or not. And at that point we say, okay, yeah, everything's going to be fine. It's all a matter of just sort of button everything up and make it look nice at this point. So we get into restuffing caps. So this might be boring for you. It's sort of a gross job, but we did it. So you heat each one individually until the innards melt, and then you pull those out, and then you throw it in the trash can, and then you're left with that nice sleeve. Sometimes you have paper capacitors where the sleeve doesn't come off gracefully, or it's a molded capacitor, but these were all sort of the solar sealed type ones with a sleeve that came off nicely. So I just labeled them all and knew which yellow capacitors they needed to go around. And you put the yellow capacitor inside the sleeve, then you seal the ends. I choose to use hot glue for that. It looks vaguely like the sealing wax that was originally used. Not perfectly, but it's something fairly easy and practical to do. And then after you've done that, then I dip it in melted beeswax. In a little cat food can, I just heat it with my heat gun. That's all that we do there. And when you get all done, you got something that looks, sort of like a new paper capacitor there. So those have the yellow caps inside. And yes.
Did you find hot glue that's in that brown color? Mostly, I've seen it be clear.
So I tried, and I've done this a few times in the past. I have in the past used sort of a tan colored, which is I think sort of the best one. I couldn't find that this time. You can get sort of deep brown. That really doesn't look right. It's too dark and too much contrast. So I ended up this time using sort of a a translucent clear-ish. It's sort of yellowy, translucent, and that seemed to be the best. I did a few of the caps with a little of the tan that I had left, and in the end, most of them got done this way. It's not perfect, but I really did scour Amazon to look for colors of glue, and I didn't see one. You really want sort of a grayish tan. That's what the original sealing wax looks like, or grayish brown. Never found it. If you know of anything that's a better match, I'd be curious.
I think maybe since I belong to Amica and they use a lot of hide glue to rebuild these automatic instruments, did you try using hide glue?
No.
I think that's the color that you want, I think. I don't know if I still have some or not, but you can find it and just look for hide glue.
All right, yeah, so Fred recommends hide glue. You know, I'm not a patient guy, though. So this is kind of quick and sort of painless. It's still a gross job, but the hide glue, you know, I'd have to wait. What's that?
You got the original coverings and you got the original values written on it. That's great.
You see, and the customer seems to be happy with it. So, but I do appreciate the suggestion. If we really had one where we really wanted to match the color, that'd be worth a try. Yeah. Okay. Cool. And the electrolytics, no big deal here. You get the innards out and put a suitable replacement inside. And then there's the deflection coupling caps and the high voltage filter caps. So these are oil filled. This is the messiest, yuckiest part of the job. So you stick them in the vise and you take the hacksaw. I think I did a Dremel actually on these. And then as you're cutting, the oil's spewing out all over everything, and the blade is spraying it on your shirt and whatnot. And maybe it has PCBs in it, although I think it might be old enough in this case that it might not. In any case, I did take a shower afterwards. And so you slice these open, and in the case of the deflection coupling caps that you see on the right, I can buy a single new little WEMA cap that's rated 2500 volts and 4700 PF, and it fits right in there, so that's easy. And then I just actually epoxied those shut with clear epoxy again to make those at the bottom. The bigger ones, I think I epoxied one of those, but it was sort of a mess, and the other one I taped, which I'll show you a few more details about that soon. But anyway, that takes care of all the capacitors. They go back into their places. And then what do we want to do with this voltage multiplier? Because it's kind of a big circuit that you saw there lying on the bench. And so I bought some small capacitors such that I could get the whole circuit inside of the first filter capacitor, which was the larger one. That's about 4 inches long by 1.25 to 1.5 inch diameter, and slice off the ends, slide this inside, drill a few extra holes for the AC feed wires. That's the green ones there that you see. And and then on one end you've got a plus terminal, on the other end you've got a minus terminal. So this is no longer a filter capacitor only, it's a filter capacitor and a voltage multiplier all hiding inside of that guy. And so when you get all done, then you have something that looks close to what you started with. It wasn't completely original as it came, but I chose to put it back the way it came because I don't have a reference of exactly how it looked straight out of the factory. And the only really egregious change is over in the right picture. You see the lower large aluminum filter cap. That's the one that's taped shut with the voltage multiplier inside. There's a great big power resistor sitting next to that that's not in the original. That's the one that drops the B plus back down to about the right level. So if you're looking carefully, you will see that particular deviation from the original appearance. And then at that point, you've got a set that more or less works as it should. These early sets I find are not rock solid performers in the synchronization department. You can see in that test pattern on the upper left, there's quite a bit of waviness to those vertical lines. There's noise getting into the synchronization. There's video content getting into the synchronization. It's possible that if I fiddled with that for a day, maybe I could fix that. But we left it. I think probably it is representative of how this set performed originally. It looks okay on normal video content. Sometimes you'll get some real waviness on vertical lines. But you can see Herman Munster looks more or less, you're right. He likes it. Yeah.
Oh, yeah, I can attach it to my electrodes.
Yeah, exactly. That would be a nice shortcut. So this is the end of the talk. This is really just a story of what this set is and restoring it. And so at that point, Nat picks it up, takes it home, verifies that the chassis is still working okay on his little table there, and then he put it back into the cabinet. And I wasn't sure how bright this picture was compared to other pre-war sets that Nat has. He's got a few others. And I guess the report is that this one is as bright or even perhaps brighter.
I think it's as bright, and I have a GE tabletop, the 171. It's probably the brightest of. I have a GE 171, which is a 5-inch version. It's this one again without the speaker below it. It's just the top half, and it's a smaller cabinet. And it's probably got the brightest picture, and it's probably because of the 5BP4 picture tube, CRT, is probably the best in that set. So I think I'm going to be looking for other 5BP4s, the best ones we can find, and switch them out and see what happens. But it's perfectly watchable in my living room, even during the day, because I have Venetian blinds and can make the room darker. And I was suggesting here that they get something to cover these windows, because in 20 years you're going to have a bunch of green wooden radios if you don't cut the sunlight down from the display rooms. So it'll be 20 years from now. We won't notice it, but. Oh, okay. Well, if it blocks the UV, yeah, then then the radios will stay good.
I have a question for you. Did you put your television online and show the beginning of the Gold Diggers of 1933 on a 5-inch set?
That would be. Trying to remember.
Yes, it's on YouTube. I put Astro Boy on the TT5, the Gold Diggers are on the TRK5, and Franklin Roosevelt is giving a talk inside the Ebbets Field baseball stadium in New York. He's talking from his car on the GE 171 tabletop set. Now the TT5 and the GE 171 require a radio for the audio. And it was basically just a trick of the two companies to sell radios. Because remember, who mentioned it here, that when CBS came out with their color system, the sets would not sell? So in order to keep the radios selling, they would say, this radio is adaptable to television. Well, it just meant you plug in a TV and use the phono jack and crank up the audio out of the radio, and you're watching a separate TV. And maybe in this museum here, there is an RCA radio that would say, adaptable for television on the front of it. It'd be like a 1939 model or 40. Yeah.
And then I have one other question before. Do you have a brush sound mirror tape recorder BK401 in your collection?
No.
Okay, that must have been somebody else then, and a RCA projection set. All right, that was somebody else. Sorry about that. There you go.
I've got one comment. I have about a half a dozen 5BP4s. If we might be able to come to some terms. And there was another thing I was going to ask, but you didn't mention anything about resistors, and I see that set all full of dumbbells. Is there any story there? Those resistors tend to be just as awful as the capacitors.
So of course I checked them, and they're not holding 5% or 10%, but they're 20%-ish, and I did not find any evidence of a circuit where it was clearly catastrophically going wrong. And because you cannot so easily replace those with anything that looks old, I let them go for now. But it's possible this set will need a resistor replaced every so often to keep it alive going forward. But I've seen other old equipment which is in much worse shape in terms of dog bone resistor drifting values. This one was not too bad. Yeah. We did, by the way, go through 4 5BP4s that Nat had, and one was much brighter than the other 3. So
Old for television, it matters a lot.
Yes.
Most of the 5 BP4s that are kicking around, including all of the ones I have, were surplus for radar sets. The first generation radar set used them, and a number of manufacturers made them, and they were optimized for radar. They didn't really have a hoot what they did in television. So I'm told that there's quite a lot of differences in their performances. And I frankly don't know which is which. The one I have that's marked GE is clearly down to air. So yeah, anyway, we could get together.
Yeah, maybe I could get one.
Well,
or whatever.
Well, you could try them all.
Yeah. Do you have a way of testing them without?
I do, but I don't know whether the testing would reveal how good they were for television, because even though I do have a tester that can test the grid cutoff characteristics, I'm not sure it would be good enough for this application. So probably the thing to do is try them in the set.
Yeah. Okay.
it's kind of handy on these sets. You don't have to put a deflection yoke on or anything. Just plug it in, try it. Yeah, exactly. And so the tests go quick. Yeah, that's what we're getting at.
Set it on a table, plug it in. That one's bright, that one's brighter, so on and so forth.
We went through the 4 tubes in what, 5 minutes?
Yeah, really.
You went through them, what, about 10 minutes?
Yeah, and very quick, very quick.
There you go.
All right.
The best one was the one that had no markings on it. Yep. The Dumont was horrible, right?
Yeah, well, all three. Next speaker is John for his second talk. And this is the talk for which I did not reveal any information this morning. The first color TV on the market. And in parentheses there, you see it was not what everybody thinks it was, the CT100. It was something else. And we'll let John explain what that's all about.
Matt, get your ass over here. Okay. Anybody? What was the first TV out, color TV out that preceded the RCA? You know, I know Matt knows. Who else knows who's the first color set? You know. You know. Everybody knows. Okay, everybody knows. What was the first color? It wasn't the CT100. That came out in April *54. Of course, it was the Westinghouse. And that was a 15-inch set. Went public on the 28th of February. That was pretty early. Because don't forget, the color standard was approved in the last week of December 1953. The Rose Bowl game, 1st of January 1954. In my write-up on that, I even remembered who won the game, and now I forgot. Anybody remember who won that game? I don't know. It doesn't really matter. Anyway, this is what the set looked like. 15-inch tube. It was the RCA tube. Had closable front doors, which was kind of interesting. Why would they want to hide that? And here's some of the advertising stuff. Nice color pictures in the magazines, the periodicals. Here's color television, early 1954. Now, I have to give thanks to Ed Wrighton, who is no longer with us, unfortunately, but he has a really great website, still up and running. I don't know who's running it, but it's...
TTF is hosting it.
Great, okay. A fellow by the name of Polar, I don't know, the Early Television Museum, and of course, lots of Ryder and Sam's data sheets, and that's where all the information from this talk came from, these particular sources. Now, Westinghouse was no stranger to television, even in 1939. Here are some Westinghouse sets. They look a little bit like TT5, TK12, and they went on. If you go back and take a look at, say, Ryder's, they made many, many sets, many different models throughout many, many years. So they were certainly part of the evolution of television. And I'll mention a little bit at the end of the talk what really finally happened with Westinghouse. They didn't disappear. They just kind of merged into something else, wound up to be actually CBS. Anyway, here were the first advertisements for this color set. The set was offered for a price of, I think, $12.95, and so the magazine, periodicals, anything, the newspapers were advertising this Westinghouse color television set for a price of, I think it was $12.95, 15-inch set. Okay. Did it sell much? No. But I have a lot of pictures that I've gleaned over the last few weeks of the set. What the set looked like. I was really curious to find out what was Westinghouse doing. Were they cloning an RCA chassis, or were they just going off completely on their own? It turns out that they were going completely off on their own, with some really crazy stuff, including, as I've already mentioned to some people, they don't even have a crystal in the burst regeneration circuit. It's a Hartley oscillator. Can you imagine?
How did they get the 358?
Well, they had it was in a phase loop, but the phase loop was disciplining not a crystal oscillator, but a Hartley oscillator. I'll come back to that and I'll show you the circuit. Okay. Now the set made the front page of Electronics magazine, very popular. I used to collect, piles of these magazines. Unfortunately, that issue of Electronics, August 1954, had nothing inside about this Westinghouse set, but it made a very nice cover picture. A couple more pictures of what the set looked like. It looked like a copper-plated chassis. The tube was incorporated onto the chassis, unlike the CT100, where the tube is in the cabinet, and you can pull the chassis of the CT100 out very easily. Very few connections you have to break, and run the chassis on your bench without even the tube connected. So the RCA was a nice set to work on. This one probably too, because the tube came with it. And here's what was in there. Most of it was somewhat conventional, starting with the tuner on the upper left. That was a turret tuner, and we all love the turret tuner. They have these what do you call them? Those little strips, biscuits. The little biscuits. There'd be one for the oscillator and the other one for the antenna and mixer and that kind of thing. These little biscuits, but it had no UHF. There were UHF strips available for these turret tuners. This set made no mention of UHF capability. Okay. Okay, but it can be done. These strips, they probably put an additional diode in there for a mixer, maybe to bypass the RF stage, but they probably worked.
John, I think the CT100 did have UHF.
It did. The CT100 was UHF compatible. The Westinghouse was not. Kurt, you've got something to say.
I do. I actually do have a 15-inch Westinghouse that was sold new in Fresno that has a standard coil tuner with a separate UHF tuner, and on the tube layout chart, they put a big X through the tuner that belonged there and then hand drew in what the standard coil tuner and UHF tube layout would be. So they did make it in UHF. They made at least one.
Okay. Thanks, Kurt. Okay. Going through the rest of it, you see they had 4 stages of video IF. It was an intercarrier sound system using a diode to detect the sound, and then going through 2 more stages of audio IF. The video detector was also a diode, a 1N64, going through, you see several stages of chroma, of luminance and chroma. The rest of it is pretty well conventional. The horizontal system used a pair of 6BD6 in the horizontal deflection, pair of them. I actually used a pair of, I'll come to that in a minute, a pair of parallel damping tubes. You can see they were using the RY and BY demodulators, so they were not using the advantage of the increased bandwidth available in the I channel. They would then add the RY and BY matrix together to get the green signal, add the luminance through a delay line to it. And of course, everybody knows why that delay line is there, because there was so much more filtering in the chrominance channel that there's a group delay, and they had to make that up with a delay line about a microsecond long. The rest of the circuit is pretty well conventional, except the color subcarrier regeneration. So here are the standouts from that schematic. It had a turret tuner, no separate UHF tuner. Intercarrier sound, it had a 1475 standard IF, not a lower or funny IF frequency. They used a 6BN6 sound detector, where you hang another resonator on one of the grids and it excites itself and detects the FM. Used an RCA 2015 GP22 CRT and very simple convergence circuitry, similar to the CT100 itself. Gilles, you have a comment.
The sound IF, you said 14, you mean 41.25 or?
The sound, it was a standard video IF, sound IF configuration, where the video IF was wide enough to include the sound carrier.
14.25, you meant 41.
A little dyslexic, I guess. All right.
So, question, if this is a 15-inch CRT, did it take that much more muscle to do the horizontal deflection than a black and white one would, that it needed to double on the damper tubes and double on the horizontal outputs?
Well, these sets required higher voltage and higher current, high voltage. Okay. And that high voltage also in these sets used a shunt regulator to regulate it. And so you've got a lot more possible draw from the horizontal system, which is supplying power to all that other stuff. Okay. Okay, I'm going to show you just a few pictures from Sam's and various other places of what the set looked like. First of all, you notice that the set actually occupied 2 chassis, and the lower chassis is power supply. I don't know what's on it besides that. It could be audio, I'm not sure. But the upper chassis looked quite clean. You know, like the CT100 has a very clean chassis. And even underneath, the RCA CT100 has a very clean chassis and very easy to work on. It's very roomy. And this set looked kind of the same. You can see the turret tuner up there, the upper right. And this set here, this picture may be of a variant of that set, which I'll talk about a little bit later, because you see an extra chassis that's hung up there on the upper left. I'll come back to what that may or may not be. Here's just some more pictures of what the inside of that set looked like. You can see here in the high voltage cage, it used 3 1B3s in a voltage tripler configuration. Very nice, this very nice copper colored chassis makeup. Nice, actually nice looking set. A couple more pictures. And you can see the set looks like it's been recapped. Another picture, and also what looks like a really good picture on the screen there. Nice looking. It looks like it's pretty well converged. I can see a little bit up at the top where it's a little bit out. Nice looking color, and that's. And it looked like the resolution was pretty good, particularly for a 15-inch set with a 15 GP22 in it, which was one of the reasons that even if you had really good color demod, the tube itself is just too coarse to really show that. Here's what the magnetics around the tube looked like. It had some static convergence magnets, purity coil up in there somewhere, field neutralizing coil at the beginning, right by the screen. Not too complicated. And the dynamic convergence, like the RCA, is almost nothing. The RCA CT100, has an electrostatic dynamic convergence. And the CT100 has two knobs, on the right-hand side of the cabinet. One of it is focus, and the other one is dynamic convergence. You move that control, and the three colors just go like this off the screen. And just to repeat, we have 4 CT100 owners here. 3 of them are in working condition. Tom, I assume that yours is in working condition.
Well, it was before I moved to Reno, and I haven't had time to put the CRT back into the set.
I've heard this before. Okay.
We'll assume that it'll still work.
All right. Okay, Tom, but tell us when it's working. Oh yes, the knobs are completely accessible.
What you need to do is you need to adjust them occasionally.
Oh, I see.
John, I can't tell you when it's working because every time I say something about the CT100, Gilles wants me to donate.
Gee, I've heard that before. All right. Okay, let's take a look at the color demodulation. Nothing particularly fancy here. You can see coming in from the upper left there, from the demodulators, the RY, B-Y demods. You'll know when you see that, you're automatically saying that they're only using a half megahertz of the I and Q signals coming through. They get matrixed together here to make the green signal. They get matrixed together with the Y signal, the luminance signal right up there at the top. You can see these matrix, and so all 3 outputs here from these amplifiers are the final red, green, and blue signals. Now, Tom, I thought I would wait to show you this. Take a look at the output amplifiers for the red, the green, and the blue gun, and you happen to notice that they've doubled up on the red gun. Tom has a knowing grin. Do you want to say something about that in your set, Tom, at this point?
10 seconds. Yeah, my CT100 has a tube with a very, very weak red gun. And so I've added a bunch of circuits and mods to try to force as much brightness out of that red gun as possible, including a big cathode follower that drives the grid positive and doesn't get sucked down by the grid current. And it kind of works.
Thanks, Tom. I thought you might appreciate that. Okay. What I was mentioning before, there is no crystal oscillator in this set. I've never seen this before. I thought every color television set had a 358 crystal oscillator in it, which then disciplined by a reactance tube or something like that. Not the case here. The oscillator is this 6AU8 right here. It's a Hartley oscillator, standard Hartley oscillator, and that other half of the 6U8 is acting as the reactance tube. And there's a phase detector circuit around all of this, which brings the oscillator to the frequency, and it also has to bring it to the correct phase. That's the most important thing, that the phase does not drift off. Otherwise, of course, you get rotation of the color matrix. Something called a color hold control. Look at that in the lower left. What in the world is that? That may be the coarse tuning of the reactance tube to bring this guy, the oscillator, into frequency, And of course, you can always tweak the A43, that coil there, to bring it also the coarse adjustment to the frequency. But I've never seen a set that didn't have a crystal oscillator in it. It's kind of interesting. Let's see, there was one other comment. I'll come back to the 19-inch version of this. Here's the output stage. I did the horizontal output, as I mentioned, 2 tubes in parallel, 6 BG6s, 2 dampers in parallel, kind of interesting, and voltage tripler, and then a shunt high voltage regulator right here. You know, these CRTs can draw up to 1 milliamps at 20 kilovolts. That's 20 watts. I mean, that's a fair amount of power that the horizontal output tubes have to provide, as well as for everything else, including B+ boost and the power that goes into the yoke itself. The small size was not a benefit. RCA stopped producing the 15 GP22 in May. They only started producing it very shortly before that. And in fact, the whole run for the CT100 only lasted about 2 months. That was it. I think about 5,000 were produced. Most were recalled. Those of us who were lucky enough to take advantage of the fact that people would not return their sets. The sets were being traded off for a 21-inch set. RCA would give you a 20, they take the 15 back, give you a 21. And aren't we lucky that there are enough people who love these sets that save them, and they're still working. And they're kind of unique because they're wideband demod, and the phosphors in these 15 GP22s have the red phosphor, the red sulfide phosphor, before they went to the orange red, and reds never looked very good after that. So
they made them in blues in Indiana.
Yeah. Indiana University, right. The consumer's reports on this set was not very kind. It said that the set was operated, the area was disturbed by ghosts, multiple images. Black and white looked okay, but color turned up. It was very annoying, weak signals, didn't look so good. You had to be skillful in tuning and adjusting this thing. So CU Consumers Report is optimistic that the next man in the future of color television. But on the basis of the evidence at hand, it appears only an inveterate, well-heeled experimenter should let the advertisements seducing him to have the very first to own a color television sets. So what happened? Well, the price really dropped fast. The set that was originally priced at $12.95 on the market, okay, that newspaper item showed, well, you can have it now for $1,100. Other newspaper item says, well, things are really slowing down. Here in the next newspaper item, you can get it for 10-1. Here you can get it for $5.95. Big discount. You can have it for $295. But at the Appliance Center over there, or wherever it is, you can have one of these sets for $199. Gilles.
I just checked the inflation calculator, and the original price would be $13,000 today.
$13,000 today for that set new. $13,000 today. We can buy an 85-inch flat screen for $400 or $500 today. Yeah. Isn't that something?
I have a question about the oscillator circuit. What kept it from drifting?
I'm going to get through that.
Good.
I think I'm going to show you a little bit more on that. Don't hold me to that because I can't remember actually whether I did or not. Anyway, the bottom line is this set now, they were trying to unload it for $199. I wonder what they paid, what the retailers paid for this set. What was their markup? But if you can have one of these things for $199, would I have bought one of these things? Oh, probably. Okay. So what did Westinghouse do? First of all, the set was obviously a no-brainer. CBS Hytron had a 19-inch tube in development, and I think you have Some of these I think you've mentioned. Yes. So what happened is this 19-inch tube was in development at CBS Hytron. RCA was also trying to make a 19-inch tube, by the way, based upon the 15GP technology. And but Westinghouse re-engineered it and gave it a new model number from H840 to H90, and you see the suffix is 15 from 19. They had a new type of tuner. It was a switch tuner, which had UHF capability. Most of the rest of the set was carried over except this thing called APC. I don't know if it's automatic phase control, automatic fixture control. I could never figure out what APC stood for. I couldn't find it in any of the literature. But they added to the burst system, and I'll come back to that. The convergence, a really elaborate convergence system was added, including many controls, far more elaborate than I saw in any of the subsequent RCA sets on this, using the 21AXP22. And the low voltage power supply used four parallels 5U4Gs. The 15-inch set used 3 of them already, but this set had 4 5U4Gs in it. That was the design of the set. And this is all, by the way, in the writers. It was the design was finished and published in the writers. But here's what the set looked like. It kind of looked like the 15-inch set, except it had a little bigger screen on it. Coming your way, new 19-inch Westinghouse color television. Well, it didn't come that way at all. It never got out of the door, actually. It never got out of the door. It was a prototype. They were working on it. They engineered the set, but it never got out of the door. But it was to use this 19VP22, and this was a CBS Hytron tube, and they were ahead of RCA in terms of the shadow mask type tube. And what this had that the RCA tube did not have is the phosphors were directly on the screen and not on a plate that's inside the tube. Okay, they were able to pull that off. RCA was developing a 19-inch tube based upon the 15-inch tube, which was clearly an end-of-the-road design. RCA really wanted to do this, and so there was a patent fight. RCA had to grit their teeth and license this CBS Hytron design into the 21AXP22. And you can imagine how RCA felt about that. All right, here's the convergence. This is just the convergence circuitry for this 19-inch set. You can see 4 triodes there that are driving a fairly elaborate set of convergence coils. Signals coming in from the left, which are already prepared in terms of their waveforms and things like that, amplified through these 4 tubes. Can you imagine? And piles of, there are about 10 pots in there as well as 4 tubes, a few variable inductors. Can you imagine trying to converge this thing? Oh boy. So what happened? The production of the set never happened, never started. Now Zworykin was at Westinghouse at the time. You know, that's where he developed the iconoscope. The iconoscope, the idea for the iconoscope was developed in the late 20s. And Zworykin was working on it at Westinghouse in the 30s, never really came up with it working that well, but Zworykin finally wound up at RCA where he perfected the tube. And so, and Zworykin went on to have a brilliant career. I think he became one of the top managers at RCA.
Okay, when Westinghouse was purchased by CBS Corporation, 1994.
I'll have another slide on that, which might elaborate on that a little bit. Westinghouse was still very much in the TV game, including KPX in San Francisco, which was a Westinghouse station. Oh, that's my last slide. Okay.
So 1994, in 1994, there was a station called KYW, Channel 3 in Philadelphia. It was Westinghouse. and it had been affiliated with NBC since it had originally come on the air before the war as a Philco station. And it was so upsetting to everybody in Philadelphia that because CBS owned Westinghouse now, that Westinghouse station and the one in Baltimore had to become CBS stations. And it was like just, outrageous, because everybody was so used to the station being the NBC station, and now it was CBS. And the former NBC, the former CBS station became the NBC station, so they just switched and had a little, you can watch it on YouTube, just NBC CBS switch some night or some evening at midnight in 1994, I think is when they made that, whenever that purchase occurred. And
W was involved with that, Group W?
oh yeah, the Group W stations, that's the Westinghouse stations, and KYW and in Philadelphia and KDKA in Pittsburgh were Westinghouse stations. Now the one in Pittsburgh originally started with Dumont, and it was WDTV, and I saw that in your ad, WDTV, and he sold it to KDKA, Westinghouse, and that killed Dumont because he no longer had a strong affiliate owned and operated. And but to the point of KDKA and KYW were so ancient as radio stations that they didn't begin with W, but they were so far east. And you could do a whole talk on the history of KYW because it changed cities and bounced around, and it was just confused the heck out of people. KYW on radio days, in the radio times, had been in Chicago, Cleveland, and Philadelphia, and back to Cleveland, and back to Philadelphia, and just, it was roaming.
I think any one of us could give long talks on any one of these specific subjects because it's all so interesting and so many things happen. Any other questions on this infamous Westinghouse top?
About the oscillator drifting, what did they do about it?
Oop, you can go first.
No, yeah, I just asked him. What about the oscillator drifting? What prevented that?
I kind of glossed over that actually, and this so-called APC circuit. Let's see if you guys, let me see if any of you guys can figure out what this is. Let me go back to that circuit. I think I've got the entire circuit here. Well, that's not the entire circuit. I guess I do not. Okay, but it turned out that what it was, for any phase lock loop, you have to provide a reference signal, and then you feed back the signal from the oscillator, run them together, run them into a phase detector, which is usually a pair of diodes, or 6AL5. Okay, and when these two signals are in frequency and they have the same phase, it'll produce a zero error signal. That error signal goes to the reactance tube and brings the oscillator onto frequency and that particular phase. Okay, so that's how any phase loop will operate. Okay, so that's the crystal is already just about on frequency, so it requires very little nudging around from the reactance tube to bring it exactly on frequency and on the correct phase. Now the heart of the oscillator can be anything. It can wander all over the place. So it has to have a very tight phase feedback loop gain around it to keep it on frequency and keep it on phase. It may be completely successful. In fact, I think most closed loop oscillators that are locked in closed loop are not crystal, but they're free running oscillators on a tight phase feedback loop. So there's nothing unusual about that. The unusual thing here is that it is not a crystal oscillator, which is a standard circuit in just about any other color television set. So it could have worked quite well. Now, this additional circuit, this APC, it could have been automatic picture control. From the oscillator, you know, one signal is brought back to this pair of diodes, which is part of the feedback loop. If you take that signal and rotate it by 90 degrees and put it onto another pair of diodes, now, if everything is working correctly, the phase feedback loop from the diodes is going to be zero, the zero correction. And anything, if it starts moving off, that value will become non-zero, go back to the reactance tube, and pull the oscillator back to where it's supposed to be. Coming from this other set of quadrature diodes that is being excited at 90 degrees, at that point, it's going to have the maximum output. Not a zero output, but a maximum output. What do you do with that? One of the things they actually did with that is they took that signal and put it into a color killer, which makes sense. If there's no burst, there's not going to be any signal there. The color killer turns off the chroma circuits, okay? But it did something else. It was also fed back into the reactance tube through a long time constant network. And that one I never figured out what in the world they were doing.
And in this circuit, is it coming in through that grid network? I mean, where's it, I don't see where it's coupling in with the reactance circuit.
Yeah, what was not being shown in this diagram is the dual diode detector, the transformer that is powering the diode, and then feedback from the oscillator back into that same phase detector. The phase detector needs two signals, the incoming sync signal and then the feedback signal from the oscillator itself. They both go into that dual diode phase detector, and that produces the error voltage that goes into the reactance tube.
So the signal for the oscillator loop, the signal's leaving one of those.
Right. It goes way around to the phase detector, which is way off to the. I should have put that in the talk. But there are basically what I'm saying is there's two phase detectors. One of them to keep the oscillator on frequency and phase, and the other phase detector at 90 degrees away that normally or usually should give a maximum output. For the color killer is a reasonable thing to do with that signal, but the signal went back into the reference tube from another, it was pulled back into the reference tube, and I don't know what it was doing. A real mystery to me. What that, was it possibly like an automatic gain control based upon the chroma intensity? In other words, if there's more chroma burst, higher chroma burst, would it increase or decrease the chroma gain? Maybe, I don't know, but I couldn't determine that by looking at the schematic, and there was nothing in the alignment procedures that even mentioned this. And this was found only in the 19-inch version. The 15-inch version did not have that.
John, you need to get one of those sets for yourself so you can examine the circuit.
Well, don't we have one? Take a look at that and see if you can figure out what that APC is doing. Take a look at it.
It's in Riders, as I recall.
It is in Riders, and everything I've got here came from Riders and Sam's.
A way of controlling the level of the color, keeping it stable.
Well, that's what I was just hinting
but the
at.
source
Kind of a color AGC based upon the burst size. Okay, because the only signal besides the signal from the oscillator itself that's getting into that phase detector is coming through the burst gate. And so anything outside the burst gate just doesn't get through. So the only thing it's looking at is coming through the burst gate. And so if the burst is changing its own amplitude, and back then, very likely it could, considering what the situation was back then with the technology, they could have been doing something like a color AGC. I mean, it's a guess, but I couldn't even determine that by looking at the schematic. Kurt, see if you can figure it out.
Yeah, I obviously never had the 19-inch version. It's obvious.
But you've got the schematics.
I've got the Riders. And it's also obvious
the cabinet for the 15-inch set was clearly designed with the idea of having a bigger tube put on it, and it looks, the pictures of the 19-inch one, now the perspective is good, whereas with the 15 it looks too small.
Yeah, that's right. It does.
Okay, anything else, Tom? Sure.
Yeah, my question's been evolving as we've been sitting here. At first I was just going to ask you, well, why can't we just use a normal Hartley oscillator? And you were clearly speculating along the same lines. Theoretically this should work okay. Most other phase-locked loops don't have a crystal. And the thought that comes to me is, in a phase-locked loop, if the resonator drifts a little bit, because the feedback gain is finite, the way that shows up is a small phase error. The more the oscillator drifts, the more phase error you got. So drifting due to temperature in the resonator, the LC coils, would have caused a shift in the hue. So I'm going to guess that that was the long-term downfall of this and why everybody else used a 3.579545.
Depends on the loop gain. We don't really.
Well, understood. If you have a really good integrator, you can drive that to zero. But I'm guessing there's a reason why they didn't practically achieve that.
This is a first order loop.
Yes, yes. So you can't have this infinite gain at zero, which would solve that problem. And then, of course, you don't have very good signal to noise on your phase source. You got this little tiny burst at the end of each line. So it's you have to do a really good job with the little bit of information you're provided. So I imagine if the error you're trying to correct is as small as possible, you have the best possible chance to get a non-drifting hue.
Also, if you lose just a little bit of time, the crystal won't move much, and this one might.
Yeah. Now I have another question. Do you think that they were trying to circumvent some patents? I mean, what reason would they do that to make this? I don't understand it.
See, no, there's nothing here that reflects any RCA circuitry at all. So I don't see any reason for circuit.
They used a whole bunch of RCA stuff elsewhere, including the tubes, the 6BD4, that were developed specifically by RCA for color television. So there's I'm sure an interesting story here. Yeah.
Yeah, I think in those days it would not have been obvious at all that you would build a phase lock loop to correct a crystal. I think most people were thinking the other way around. You build a phase lock loop to get a LC to follow a crystal at the station. So it just may not have occurred to anybody that you would build a phase lock loop around a crystal. You always do it around a free running LC oscillator. But once somebody did it, it was clear that, the crystal's a much better idea. That's just wild speculation, but I'm wondering if that's the way it went.
That sounds like a good idea. Anybody else? Okay, thanks. Thanks, you guys.
Thanks.
Okay, so we're down to our final talk and continuing today's major theme of color stuff. We're going to have Nat Pendleton talk to us. I'll get that set up for if you want to. You can even begin your presentation while I bring this.
Okay, so this is going to be sort of the history of color TV as from the viewer's point of view. In other words, what would an average citizen who subscribed to TV Guide and those kind of listings and read newspapers know about color TV and think about it, and why did it take so long to really launch it? It took about 10 years to get it off the ground. When you're talking about the introduction of commercial color television in 1954 to maybe about 1964, 65, when it started to really get known what it was. So, okay, let's begin. So, first of all, I'm not going to be talking about the early development of it. I did read articles about how CBS, they even took a TRK-9, this beautiful TRK-9, and stuck a color wheel in front of it and transmitted on the UHF band and picked it up off the Chrysler building and demonstrated it to the press, basically. They showed it, we can do it, and then the war came. All right. So, if you're looking at a timeline, there was a blip in 1951 where CBS came out with a big band, made a lot of noise, and that was the end of color TV. And I'll talk a little bit about that. And then you have in newspapers and even in TV Guide, there's 2 TV Guides in 1953. Now let me go quick history of TV Guide. It started in New York and in Chicago and in Philadelphia under different names. It was TV Guide in New York, TV Digest in Pittsburgh and Philadelphia, and in Chicago it was called TV Forecast. And the formats and everything look quite different on each of the magazines. And they didn't merge until the spring of April of 1953. It became a national magazine, and it marketed in maybe about 15 cities. And there's these 2 issues in 1953 that you'll see some color pictures of in a minute, that deal with color television, that talk about the arrival of color television before it became commercial. So it was 1953, RCA is doing their demos to FCC and field tests. And then you take a look when they finally get it out in 1954. And I say field tests only to April of 1954 because it didn't sell sets. How are you going to watch it? There was maybe like a transmission per month in January, February, March. And then in April, they started slowly picking it up. And over the summertime, you got maybe 2 shows a week, 3 shows a week on the NBC affiliate and an occasional CBS demo of color. So by 1955, under 0.5% of the country would have had a color TV set. By 1960, after Bonanza had already been on the air for a year, but before The Wonderful World of Color came on, the census indicated 2%, around 2% of the population had color TV. And then in 1965, it really starts to take off because NBC started advertising that it was the full color network. All the broadcasts that NBC made over their network were supposed to be in color, and almost all of them were. Then in '66, the other 2 networks, ABC, NBC, joined. So when people started noticing that all the programs were being transmitted in color, that would be a big impetus to go out and maybe buy a set. And in 1970, you reached the halfway point. 50% of the homes had a color set. Okay, enough on the census. There is a slave unit at ETF in Ohio that goes over your Columbia Hytron black and white television set, and there's a scanning disc unit is inside it. And then they also have an actual full set, the entire set that has the color wheel slides in and out automatically. And I actually saw it demonstrated in Ed Raitan's home down in Los Angeles. He showed me his TV set, and he said it was one of 2 because all the other 400 were recalled. So there was only a month where there were actually sets being sold, and then, oops, this is a bad idea, let's get out of it, and they bailed. Okay, so here's some still photographs in black and white, conveniently, showing how they demonstrated some programs. And they ran a 2-hour broadcast, actually it's only 1 hour, over a 5-station network. So it originated in New York City and went down to Philadelphia, Baltimore, Washington, D.C., and up to Boston. And those were the only cities that had the CBS color system demonstrated. So it didn't even make the full network. It only ran in 5 cities. This is what it would, here's some screenshots that were taken and published in Life magazine. So you can see Arthur Godfrey, some advertising, Ed Sullivan, and there's the so-called bloodshot eye of CBS up in the upper left. They actually introduced it in the mechanical scan, and then they reused this in the 50s on the electronic system as well. It's a kaleidoscope, really. And there's their test pattern, more advertising, and some of the programming. Okay. Now, this one here, we're going back to your discussion of color balance and all of that. This one, this comment just cracked me up. It was written in a magazine that I have called Televisor, and you can just read the quotation up there about how the thing about cheap taste, and it's going to be abused, and they're going to have garish colors. It's terrible. And so he's begging the people to show a little bit of discipline. It's just the last line there is a control in a mad battle to outbedazzle the eyes of the beholder is too harrowing to contemplate. So a bit of drama there from somebody in 1951 in July. So the demo happened on June 25th, 1951, where they had that 5-network hookup, and those color pictures that you saw and the pictures of Arthur Godfrey and Ed Sullivan and so on, that program was broadcast on June 25th, 1951. And I checked, and I've been looking for that TV guide, and the most horrible thing happened. It has on the cover, hold it, Martin and Lewis, okay? The 2 comedians, Martin and Jerry Lewis. And everybody's trying to sell them for like $150 a magazine. It's absurd. Whereas this one came a little cheaper because nobody remembers. You know, Sid Caesar, who's he? But
So this magazine was the following week, but it had the articles in it. This is the New York edition of TV Guide, and it's before it became a national magazine again. So it looks quite different. But basically, it talks about the article, and it basically says it's not ready for prime time. Okay, inanimate objects look beautiful, but when things moved, the colors would change because of the scanning of flying wheels and everything in the fields. The colors would blur. So a red jerseyed football player running across the street might turn green, and then he changes teams, right? Flesh tones did it. So Dumont had demonstrated the RCA tricolor television at the same time. So remember, the compatible system was still in the lab while CBS was broadcasting all of this. And so the article here in the middle of this magazine talks about all of this. It's actually interesting. The public would have heard of RCA and NBC's tests, but then they see that CBS is the way to go. And here's a close-up of that article. I don't know if you can read anything here. So when that program showed on 25th of June in 1951, there were no sets. There were no converters. There were whatever CBS had to demonstrate to reporters. And the author here, Mr. Sinclair, talks about RCA still being at it. RCA is going to come through. Maybe they keep working on it on the compatible system. He mentions the cost will be high. We all know that from your experience with the Westinghouse set. But the CBS color sets were priced at around $800 to $1,000, and this is with a spinning wheel in front of it. And of course, there were hardly any shows, and they were not compatible. So I put blue dots next so you don't have to look for the color program, but you can see that Modern Homemakers ran for half an hour on Channel 2 in New York City. And then they ran The World Is Yours, which is a nature show, and nobody could watch it unless they had adapted their black and white set to the different frame rates, etc., and done the technical modifications. And so just hobbyists were the only ones that really did that. And some of them even got a fan motor and a variac and put a color wheel in front. And those have been the only people that would have seen color TV because they still hadn't sold their $1,000 television sets. They're still making them, I guess. All right, so incompatible. And the reason they got out, CBS says, is because of the war, the Korean War. Oh, we got to get out. Well, the thing is that, yes, they stopped making color sets, but making black and white sets continued at a fervorish pace. And why not? I mean, people wanted television sets, and there's really nothing different between materials and cost of materials with a color set and with the black and white sets that were being made. It was just transistors, and not transistors, tubes and capacitors and resistors and steel for the frames and CRTs. I mean,
all sets went up in 1953 when I had this.
What? No. They didn't stop making black and white sets, just the color set. But that was the excuse. CBS saw that it was not working. It just, because it was incompatible, it was expensive, and even though they were, in their publicity campaign, you don't put stuff on the air and tell everybody about it when there's no sets out there. They couldn't even go down to the TV store and look at one in the window. So it kind of makes you feel like the Real McCoys, you don't have a TV set. So they got their black eye, as you can see. Then NBC comes strutting along, and the Peacock doesn't come out till later, but so I just had to put a Peacock on there, though. But they're known for the Peacock. It came out in 1956. And so NBC rolls out their color system, and there's actually some publicity about their color system. It wasn't kept under wraps. They were proud of it. And so there's an article in the June 26th edition of TV Guide about some of the demonstrations that they made to the FCC. Now, this is almost exactly 2 years after the CBS system was introduced and then withdrawn. 2 years later, you get discussion of what they're calling the RCA compatible color system. And I think they called it NTSC when it got officially approved by the FCC in December 17th, 1953. So 1953 is this interesting warm-up year. Here's the TV guide that talks about it in the article, and they're mentioning that it's pending approval, it is a compatible system, and we hope to have color television in your home by Christmas. They're always so optimistic with color TV. Didn't happen, but they were hoping to have it. However, there was some exposure to it. There's no further mention in this article, by the way, of the non-compatible system of CBS, but Dumont, somewhere around the bottom of this paragraph here, is saying we're going to have 3D television soon. So Dumont is hoping that there'll be a 3D system out there soon. So it was kind of getting off the rails there. But it'll take a long time to do all that because of the cost. All right. So here's what happened in '53 according to the TV Guide articles. Okay. On August 30th, they did a special color broadcast of Kukla, Fran and Ollie, straight out of Chicago. So I found a TV guide that lists Kukla, Fran and Ollie, and it's the Chicago one. They're proud of their native son, the Chicago School of Television, where the programming that came out of Chicago was a little different, a little more avant-garde perhaps, and crazy. So Kukla, Fran and Ollie did their show. Again, it talks about doing a repeat performance. Well, it's because the original performance, whether it was filmed or not, was black and white. So they did the performance again, and they had it in color. Then you'll see the other dates. We'll get to them in a minute, but you have an opera, Carmen. Then you have the Colgate Comedy Hour, and then the approval by the FCC. And immediately, within an hour, NBC and CBS are rushing to get something on the air in color just to do it. It's not going to be published in any TV guide because they did it on the spur of the moment after the approval. So there's no listings for it. Not even the programs that they did. They just did it. Okay. So here's the Kukla, Fran and Ollie one. And there's no mention of color in it. It was done in color. Ed Reitan's website tells you about it. However, it was a big show. They used Arthur Fiedler and the NBC Symphony Orchestra to do this kind of operatic performance, okay, of St. George and the Dragon. And we know who the dragon was. And it was all semi-serious, and I think adults really watched it more than the kids. The kids probably fell asleep on the sofa. Okay. Then came the opera Carmen, and this had a little more publicity to it. Go ahead and read up here. This is an excerpt from what you call the TV Guide close-up, or a long description of what the program was. It was a full-page description. Most of it was dedicated to what the opera was about and who was starring in it. But the initial part says, want to know what color TV will look like on a black and white, on your present black and white set? Then watch this 1-hour version of Bizet's Carmen in English. The season's opening, telecast NBC Opera Theater. The entire program will be transmitted in the RCA-compatible color system. The results should put to rest any worries you might have about the usefulness of your black and white TV set in the color TV world of the future. In other words, people knew the show was going to be in color if they read the TV Guide. And they watched it in black and white, and apparently it came off fine. They wouldn't have known otherwise. Okay, then on November 22nd, you have the Comedy Hour. And there's the New York City one, and here's the TV Guide from Cleveland. I'll read the Cleveland one because it's the funniest. Comedy Hour, Variety on Channel 4 and 73. 73 was WFMJ, Youngstown, Ohio, and they moved down to Channel 21 a couple years later because you know how Channel 73 could go about 2 blocks maybe? Very low power. It's just inefficient, super high frequency. Okay, so Comedy Hour, Variety. Donald O'Connor stars with guests Sid Miller, Corinne Calvet, and Dorothy Dandridge. This is the first color telecast of the show and will also be seen in black and white in colorless Cleveland. So Cleveland is it's wintertime. They're on the lake. The lake catches fire. It's gray. It's polluted. So colorless Cleveland. And the other one on the New York edition tells you it'll be seen in black and white on your monochrome set. Okay. This is actually available on YouTube in black and white. It's a kinescope, unfortunately. They made a Technicolor film, and I'm trying to remember what the name of it was. The Big Jesus or something like that. It's where a little boy, I don't want to ruin the plot, but a little boy stole the Christ child out of the church's display, out of the manger. And the reason he did is he wanted to give Jesus a ride in his little red wagon because he was grateful that he was given the red wagon. Meanwhile, Joe Friday and the priest are talking, who could take it? Who would do such a low thing? And then this little kid shows up with the Christ child in the wagon, and they give it back. And it's a very touching episode, but it's on YouTube, but in black and white. But if you watch it to the very end, you'll see filmed in Technicolor at the such and such studios and at the Los Angeles Mission, the original church. So that was the last color broadcast in 1953. And again, the TV guide doesn't even mention it's in color. So it's very sporadic. Okay, so let's get into 1954. Okay. The Tournament of Roses. Okay. You can see down in the middle here, it'll say, the parade will be telecast in color through the use of the only fully equipped color mobile unit in existence. So this was January 1st. This is out of the New York TV guide. It went over like 12 different stations. It came out of Los Angeles, came up to San Francisco, and then went east and through Denver, and then back east. It went through Cleveland and was seen in black and white. So Ed Reitan actually wrote, I couldn't find it, but I remember reading it one time. It was talking about when he was a child of about 8 years old, his father took him down to the Grand Hotel in Omaha, Nebraska, and he saw it in color on two Model 5s, or the predecessor of the CT100. It was the RCA field test version of the CT100 that wasn't sold, but it was being demonstrated. They basically put up a couple of color TV sets in the biggest hotel or city hall or biggest venue they could find in each city that had color television. And it went all the way back east. It went through Johnstown, but not Pittsburgh. So Johnstown, Pennsylvania would have had it. Lancaster had it, really small town. Philadelphia, New York, and then up to Boston. One station in their very first color network had a UHF station. And so that would be the oldest UHF station to have color television. They had a RCA color transmitter, and it was in Scranton, Pennsylvania. WBRE, Channel 28. And I couldn't find the TV guide at the time, but there is this ad for their station in the summer of 1954 saying, first in color. We've had color television since January 1st of 1954. Okay, so there's the TV guide if you want to go on eBay and find one that has the listings. Curiously, not all the editions mention the color, but most of them do, because I think RCA put out some information. They let people know. So there's the Tournament of Roses on a CT100, Bing, and just the local New York version of it. And it's interesting, they don't show in color because nobody's going to be watching it in color unless you go to the one venue where they would be demonstrating the sets. Okay. That issue also had color TV facts, and they talked about how CBS had plans, NBC had plans, Dumont had plans and wasn't specific about them. Dumont never went color. ABC didn't care about it. They didn't want anything to do with it. Because they saw what happened in 1951. It was a fiasco. Why would we get involved in it so early? And the prices of the different sets, you can maybe see some of the brand names and the cost ranges that they're giving for the different sets, and the sizes of the pictures.
It's all out of conjecture when all they have really are some field test receivers with 15-inch screens. That was it on January 1st. So there are the plans, and CBS was really pretty active. That was a CBS program, the one called The Marriage. That was a CBS weekly program that they did in color. And NBC had a series called Norby, and neither of them survived. They lasted about a year, and I guess the writing was poor or something. They weren't classic programs, apparently. But those were the first two shows, regular television programs that were done weekly in color. And then CBS also would use that same mobile television unit that they used in Pasadena for the Rose Bowl parade, and they hauled it around the country. And in this one, mobile unit visits the Karamu Settlement House in Cleveland, Ohio. I guess they heard that thing about the colorless Cleveland, and they wanted to appease them. So it talks about the interview and all that. But the program, the Today Show that morning on Thursday, only that once. If you look on the other days, it's not in color. It's just that one episode. The Thursday morning show is done in color. And since that's July 8th, there might have been 5 people to 10 people in Pittsburgh that had a CT100. You know, some of the industrialists perhaps, or the TV network executive, or the owner of Westinghouse. Who knows? A few people had color TVs. Okay. So CBS also tried broadcasting each one of their main television shows in color. And here's an issue where it was Burns and Allen, the Burns and Allen show. It's the life and the time of, in Burns and Allen, the earliest episodes is mostly stand-up, and then it goes into your typical sitcom where they're living in their home and they have the Von Zells are their neighbors. It's that version of the Burns and Allen show. And it ran on YouTube for a while, and I have not been able to find it. It probably got sucked off by some copyright holder. So it's not there anymore. But it was in nice pinkish purpley color because the film had faded. So it didn't look all that good. Yes?
Did CBS have to buy RCA cameras to do that?
CBS stuck color wheels in front of their cameras and then converted it to an NTSC signal. Chromacolor units, yes. And that's how CBS did the studio end of it. But they did later buy TK41 cameras, because I've seen photographs of CBS people using TK41s. But initially they used these Chromacolor cameras.
Read my article on Chromacolor.
Okay, so there were these things called color spectaculars, and once a month there was this program producer named Max Liebman, and he put on spectaculars. So the first one was a complete flop, probably because the plot wasn't any good, the songs were not well known. It's not like Sound of Music or something where you recognize the songs. And there were very few color sets still in September. But the biggest disaster was probably because it ran against Ed Sullivan. And that was like the #1 show on CBS. And so this is 54, September of 54. Again, those 5 people in Pittsburgh and now 7 in Philadelphia are watching in color. You know, those with CT100s and Westinghouse, of course, and a few others. Okay, and there's the cover and the description of it from the Pittsburgh TV Guide. And there would be the monthly spectaculars that followed were usually much better. Okay, one of them was Amel and the Night Visitors. Does anybody recall that? Okay. It was an NBC annual show, and they started putting that in color. The same week that this ran, okay, so this is 7:30 on Sunday night, and the same week, CBS, of course, has to have something as well, so they do something in color, and that's their program. So this is so early that you have to dig for it in the TV guides, because not all the editions even talk about it being in color. The little logo up there, just color in parentheses. Not all the editions would tout that, because they
the editors weren't aware of in the local editions. But by 1955, it starts to become a lot more familiar. And this was made famous by videotaping it in like 1958 or 59, and then it was preserved and kept as a museum artifact, and now I think it's on YouTube, but you can watch Peter Pan, and it is slow moving. It's a stage production. It's so slow moving that for people like us today, it's boring, but it's in color. So but they were watching this stage play in color, and it was done live for several years, and then they videotaped it. When they had there was no videotape in 1955. But this is something that's a little more well known, so I featured it. Now we go to something I actually remember. The premiere of The Wonderful World of Color. Now, I don't think I saw the premiere episode, although that is on YouTube as well. You can look up, and it'll have Mathemagic Land is one of the episodes, and it's all about math, and the other is about color. And it's Ludwig van Drake with his German accent talking all about, there he is, his little drawing there. Ludwig van Drake is introduced, and he talks about color. And it's kind of funny to watch, so go ahead and watch it tonight sometime on YouTube. All right, and this is the first time I ever saw color TV. I was watching an episode of Disney with lots of animation, and it blew me away. And my sister and I never left my father alone. Hey, get a color TV, get a color TV, get a color. It was at a wealthy person's house up the street. Yeah, we didn't watch it at home, and so we kept bothering my father. He got a color TV, and I'll tell you why we never got a color TV until about 1970. And I'll tell you why in a minute. Just ask me. I might try to remember. Okay, in the mid-50s, 1956, these were the television stations that produced local color. So that added to the amount of color that you could view, because they would do their local news and a kids show and perhaps a talk show of some sort during the day in color. So that's the list of all the stations. You can locate the ones here in the West. Is Fresno there? Yes, upper left. Okay, so yeah, KJEO. Fresno actually had a color station, which is pretty good, because not all cities had color TV stations. All right, so here's some slides taken from RCA's Broadcast News magazine, and I'm just going to flip through here. Most of them are NBC affiliates. Okay, all right, Dallas, Houston, Dallas market. And them bragging about it. And that's with the city a viewer population, the number of TV sets. So maybe 500,000 people were watching black and white television at that time. Okay, this one was in your range, maybe, your neck of the woods. Here's the one that Ed Reitan would have seen out of Omaha, Nebraska. Right? And here's Charlotte. Now this one was a CBS affiliate, mainly, and some NBC programs, and they were originating their color. So it wasn't just NBC. But you'll notice that the next one, the color van up here, Mummers Parade is kind of like, I don't even know how to describe it. They say that it's Dutch in origin, and it's kind of like those New Orleans parades, Mardi Gras kind of thing. It's just a bunch of crazy people dressed up in wild uniforms walking down the street and playing, they call them string bands. They play banjos and walk down the street. Well, it was broadcast in color in 1956 on the CBS affiliate. And notice the make of the wagon, RCA color television, on a CBS van. Well, it was owned by the newspaper at the time. And here's one that, having grown up in the Philadelphia area, is especially interesting, because I remember going over to a friend's house and watching cartoons in color on WFIL Channel 6, which is the ABC station. And it broadcast things in color, but when it went to the network on ABC, it was always black and white. And they would broadcast
every week, American Bandstand in color, but the ABC network picked it up and retransmitted it in black and white. So only Philadelphia saw American Bandstand in color in the early years with Dick Clark. And you can see it's listed there on Channel 6, color, Clark. Okay. Then this gets into the practical thing. Why would they have a 1-hour matinee movie called Matinee Theater all through the mid-50s at 3 o'clock? Why would they have a thing in color then? And then Howdy Doody at 5:30. Think about the logistics for a minute. How are you going to sell a color set unless there's something in color on it and the TV store is open during the day? So people that were shopping at 3 o'clock to 4 o'clock might happen into the TV store and they could see the demo of these new expensive boxes that produce beautiful pictures. And then again at 5:30 after work, even though it was a kids show, they could see the color of the studio for Howdy Doody. So yeah, that's 1955. That's pretty early, but they're demonstrating those new 21-inch sets, big color TV. And here's one of them from the December issue of National Geographic. Any of you who are into art or design, look at the picture. Notice where the color is. Besides the people and their faces, everything is white. It's just a boring white Christmas until you look into the magic of the TV. So that's from December. That was for December of 1955 that they're trying to sell this TV set. And it's down to $900. It's a little cheaper. So what do these shows have in common? Look at all the titles. Do you remember any of these TV shows? What do they all have in common? They started in black and white, and they turned to color. They continued on the air in color, okay? I remember that very well, because I remember seeing the little black C's appearing after what had originally been black and white shows, and they put the little black C after the program to tell you it's in color, which didn't enter our house, but, and now I'll tell you why. We finally got a color TV after my dad went on a road trip for his job, and he was traveling, and my mom took me to a TV store and said, "Do you like this TV set?" And I said, "Yeah." It was an RCA tabletop 16-inch television set from 1970, still used tubes, and she bought it, and we got it home. And then my dad got home that Sunday night. We're kind of wondering, what's he going to say about this, because we went out unbeknownst to him and bought a color TV. So my dad comes into the house, and I was watching the TV, and the program was in color. I don't remember what it was, but I was watching some color show, and he was chatting with my mom, telling her all about the trip. And in the middle of the conversation, he goes, "Is that a color TV?" Because he would have failed your test, the one with the numbers. That's why we didn't get a color TV. He didn't think it was all that special because he was color weak. So he wouldn't have been able to see those 7s and 5s or whatever in your dot matrix things. Okay, so these are the shows that went to color. Okay. And then this is the year, if you can see in the full color network, this is out of an Eastern Pennsylvania TV guide. There's the UHF station, WBRE Scranton, the first UHF station to go into color. And they started calling themselves the Full Color Network. And because of that, people started to think, oh, if I buy a color TV set, there'll be things on it to see every evening in color on all the networks eventually. And so by 1966, all the 3 networks, were transmitting programs in color. And the only black and white things were old movies and daytime programming, which we don't care about, and you come home, you relax, and you watch programs in color if you bought one of those TV sets. Okay, so by 1970, half, and that's the year we got our TV, our color TV. We got it in 1970, so we're very average Americans. And my dad said, "Is that a color TV?" Okay, so are there any questions about how color TV rolled out or how people reacted to it, or any anecdotes that you have to talk about? Yes.
Just curious, I noticed that most of the early color broadcasts were done on the VHF low band.
Mm-hmm.
Why is that?
Oh, those just happened to be the TV guides I had. But if you go, there you have Lancaster, Channel 8, and 28 is out of Scranton. And, okay, that's 1966. But they did have all frequencies that they could have a color transmitter. It just happened to be that I was showing you New York and Philadelphia. So New York was channel 4, Philadelphia was channel 3 for MDC, low band stations. Okay, so I hope, oh yeah, yes.
I just have a question. When they transmitted the Rose Parade, since Westinghouse sold that set in December, do you think any average people, not average, but higher income people bought some of those sets and were able to watch it?
Did Westinghouse sell their set in December of 50?
I don't think so.
53?
February.
Oh, it was February?
This was February 53.
Oh, February
54.
February 54. Oh, okay. I thought they came out with it in December.
Rose Parade was New Year's Day before. Well, so it was just watching it in the lobby of hotels.
I see. Okay. I thought they came out in December, but anyway.
Well, they had the commercially sold color sets. The first was April, right? And then the CT100 was a couple weeks later.
Oh, CT100 was April.
April.
Yeah.
Okay.
Okay.
I've got two anecdotes. The first is I have a friend who was the son of a high RCA executive, and RCA gave them a first generation color set for their home, but when company was over, if they were watching TV, the condition was they had to also have a black and white set turned on right next to it simultaneously. So you could see the difference between color and black and white when there was a color broadcast and when there wasn't. So you could see that the color set could make black and white pictures just fine, and the black and white set couldn't tell any difference, and it was more spectacular in color. Also, I knew a broadcast engineer who was one of the initial engineers with KCRA TV in Sacramento, which went on the air. The license was granted in 54, but they weren't on your list. I think they didn't actually get on the air maybe until 55. And the color monitor that I have from KCRA, the CRT code date is actually from 55. So I'm guessing that was an original tube for that. But anyway, he made a comment that the family that owned the station went on the air as a color station. They were having a party, and they had guests over, and of course they were just running some old black and white movie. It was evening, and the engineer is on duty. He gets a call that says, "Put on color." Well, they didn't have anything in color in-house. They had the cameras, but there was nobody to operate the color cameras, and they didn't have any film. They had a color film chain, but they didn't have any color films. So he put up test bars. And the party got to see the test bars in color, and the rest of the world got to see the test bars in black and white.
Okay, so the very first one of color TV that I saw, I was 5 years old, and it was 1961, and it was at a wealthy person's house, and they had invited all the kids to show them their new toy, a color TV. Later, probably around 63, 64, 65, I would go over to a friend's house occasionally. His name was Steve Nelson, and his father was an RCA engineer, and they had a CT100. Yep, and he knew how to operate it and keep it running. And so we would watch Popeye cartoons and Bugs Bunny cartoons in color on a local program called Sally Star. And I remember the thing that was amazing was she was in black and white. The live lady hostess of the program was in black and white, and the cartoons were in color. And I never understood that until later, finding out, well, they had a film chain in color, but they didn't have anybody to operate a TK41 camera for that every day, so they just didn't schedule it to do live. They did more film chain stuff. And in the RCA broadcast news, when they're selling you this equipment, they'll say, build your TV station step by step to go color. first thing you do is you can transmit network color. It was a lot of stations, that's all they could do. The one on that list, those stations had either film chains or even went as far as having a studio. Okay, so some of the famous stations, so Philadelphia was Channel 6, the ABC station. Chicago had WGN, they went to color in like 55 and did Bozo in color with the cameras and the whole thing. I mean, the actual clown was in color. And the second program, though, I remember seeing in color was The Wizard of Oz, and I remember being totally amazed. The witch is green. I didn't know that, because I'd seen it several years before that in black and white, and then when I saw The Wizard of Oz finally in color, I noticed the witch was green. So that was a big surprise. So many anecdotes, but...
Just a comment on the network. On the networks themselves, the cross-country networks at that time, early, were not capable of carrying across the country a full high-fidelity, phase-coherent color signal. So I think, if my memory serves me right, they would take the color subcarrier, take it down to about 2.5 megahertz, and transmit the color signal with the color subcarrier taken down to about 2.5 megahertz, because the up around 4, the transmission was not that good, and then reconstitute it once it gets to the station, bring that color signal back up. Only later on was the cross-country network capable of handling a full color signal.
So they must have had adapted transmitters, these converters.
Well, the transmitters were broadcasting the standard signal. Within the studio, there was the circuit that would take that lower subcarrier, put it back up, and then transmit it.
Okay. Yeah.
Because there were also, back in the day, there were retransmission centers. I know we sold equipment to one called the Rocky Mountain Broadcast Network. And all they did was take in signals from all these networks and retransmit them at full bandwidth again back out for the West Coast.
Huh.
And a lot of those were located in Denver, just because of its proximity in the middle of the country.
Mm-hmm.
I think that led to the NTSC 7 standards, where the AT&T long lines established very high quality transmission. And I have the full set of standards where you had to maintain differential phase, differential gain, chrominance, luminance, inequality, everything nearly perfect. And that's when Tektronix had their high points in selling test equipment as well. So there was a point where they didn't play with the colors. They didn't play the U-matic color subcarrier trick. They left everything in place and retransmitted.
After the networks could transmit without distortion.
Yeah, and they introduced the vertical interval reference signals.
They mainly on the East Coast.
Yeah.
Where they played this trick until the networks got better.
Mm-hmm. Well, some of the advertising in these trade magazines from like 54, 55, 56 is for, of course, for color equipment, but there's also, I saw some AT&T ads saying, yes, we can carry the color signal and do it successfully, and all our great engineers are bringing you color TV on a nationwide basis. So AT&T was also involved in tooting their horn a little bit.
Now, this probably pertains, I guess, to John Staples can answer this question. Originally, when NTSC color came around, in the very beginning, it wasn't really 100% compatible with black and white. They had to narrow the bandwidth of luminance, right? For the 3.58, but they were able to resolve that issue. Can you comment about that? They lost sharpness in the video with black and white, and they ran color captures over there.
Oh, I'm not quite sure what your question is, but I'm not sure what the answer to your question is, whether the luminance signal was degraded in some of these network lines. The answer is probably yes. It's probably related to the very early stages. Well, okay, I think, Gilles, why don't you answer his question? I think you have a better knowledge of that than I do.
The NTSC standard called very clearly for an upper luminance bandwidth or resolution bandwidth of 4.18 megahertz exactly, not 4.2, 4.18. And you had to transmit that. And the whole point of frequency interleaving with the color subcarrier is that the chrominance wouldn't show up on black and white TV sets, as you've explained very well. But I don't believe they degraded black and white TV sets for that.
I didn't think so either. I mean, the only point that I was making is that the transmission standards at the very beginning, 1954, were not up to the standards.
At the very beginning, it may not be.
So they were playing this trick of moving the subcarrier down.
It's interesting to see the advertising in the first RCA TV catalog, to see their first waveform monitor, which they call an oscilloscope, which is about the size of that speaker console for measuring the parameters, you know.
Well, I think probably from here, we encourage all these conversations to continue, but maybe we'll end the formal part of the session and you can mill around and talk as you see fit, unless there's some particular question that somebody still wants to make sure gets recorded for posterity or anything like that.
Thank you.
Okay. Yeah, all right. And thank you for all of your attendance. It's the very interesting knowledge and history that all you have that make this event a fun one to hold. I should mention, you know, I've been serving as the caretaker for this, and I can continue to do that. But at any point, if some of you have some ideas of things we can do to improve this event, or even if you'd like to take charge for a year and do it your way or anything like that, I'm totally open to whatever works for the group, and let's go forward with that. But feel free to mention ideas for future improvements, and we'll strive to do that. Otherwise, I think we are finished for today, unless there is anything else that people know of. All right. You're most welcome. All right.